Dr. Imayul, good evening, good morning, good afternoon.
Good evening. Good afternoon. Can you hear me well?
Dr. Imayul? Yeah, good to see you.
Very nice to see you. Very happy to see you and very happy to participate in this session. Thank you very much for inviting me.
No, I'm thankful to you for accepting our invitation and attending our program for success.
Thank you very much. Should I wait a bit before we start?
Just I'm waiting.
Okay, so let me know whenever you're ready.
Yeah, just for a couple of minutes.
No problem, no problem, no problem. Thank you.
Dr. Subramaniam.
Namaskar, sir.
Sir, namaskar. Now I ask Shalini.
Good evening, everybody. A warm welcome to you all, the organizers, the speakers, the participants, and the guests. I welcome you all on the third day of the international workshop on the application of GIS and remote sensing. Since last 2 days, we had been listening to the different speakers from India as well as abroad, and their highlighting lectures and the research work have enlightened many of these research scholars and the research professionals. Today we are going to start. Today is the third day and the final day of the program. I invite Dr. Subramaniam sir to chair the session for today's program. Dr. Subramaniam sir.
Thank you very much, Dr. Shalini. First of all, I thank the organizer for giving me the opportunity to conduct this session. And before I just go, I just want to know how many papers are there? Is there any dropouts? And what is the total time available so that we can just tell the speakers how much they should just take per one paper? Because you have got a valedictory function also after this session. So we have to have the time management. So accordingly, we can plan.
Sir, there are 6 papers, 6 presentations today, and all speakers are available. So half hour each. There will be 6 presentations, sir, and then will be valedictory for half an hour after that.
After that, so everybody can have about half an hour presentation time.
Yes, sir.
Achha, then the order of the serial order also it is given as per the program sheet.
Yes, sir, it is same.
It is same.
Yeah.
Okay. So with this prelude, I first of all I invite all the speakers to be just ready, and you are just seen the time management also, because the organizers, they just said everybody should just take only about 30 minutes. So if you all agree, we can just have about 25 minutes of the presentation each paper, and 5 minutes we can have 1 or 2 questions. And in case if you overshoot the time, probably the questions can be sent to the organizers. So they will get it from they will get the answers from the speakers, and they will just send all the answers through email. So with this, first of all, I invite Dr. Emmanuel Vorokchikis. I think my vocabulary is right. I'm
Very good, no problem. Very nice.
Okay. And present his paper. And what I will do, I'll not just take much time. Just after the speaker is completed his talk, I will not just give my brief. I will just try to give the brief at the end of the session. What is that speaker they just told? I'll summarize it at the end of the session just to save the time. So with this, I invite and I request Dr. Emmanuel to just present his paper.
Thank you very much for the invitation. I will share my screen first.
Just one more interruption. I request Dr. Shalini to just give a brief introduction about the speaker.
Yeah, I welcome Dr. Inamal Varanchakis.
Varoufakis, yes.
I hope
no
I am
problem.
right. If I
No
pronounce
problem,
it
it's good.
wrong, I apologize for the same.
No problem
I
at
would
all.
like to give a brief introduction to all the participants. Professor has completed his PhD from the Technical University of Crete, and he has been awarded for the International Association for Mathematical Geosciences. He has published his research papers in various national and the international journals, and different projects has been accomplished by him at the international level. Presently, he is working in the Geo-Environmental Engineering Laboratory, Technical University of Crete, Greece. A warm welcome to you, Professor.
Thank you very much for the introduction. Thank you very much for. I would like to thank the organizing committee for inviting me to give this this talk. The title of my presentation, as you can see in the screen, is Spatiotemporal Geostatistical Modeling of Aquifer Levels using Physically Based Tools. Part of this work has been funded from the National Association of Mathematical Geosciences and from Prince Albert of Monaco Foundation. It's a work of the past several papers of the past few years, and I would like to introduce a complete now methodology and talk about also its future. So first, I also would like to thank my colleague and Dr. Kordzo, who's a member of the committee, because a lot of research topics that are going to be presented today has been performed with his also collaboration. So my talk, the outline of my talk is it's going to be separated in different items. First, we're going to talk about the aim and scope, a short introduction about space-time geostatistics for those that are not familiar with the discipline. I'm going to discuss the methodology that is proposed for the groundwater modeling. About also, I'm going to talk about the case study. Then we'll discuss the implications. I don't know why this is happening. This is actually occurring in the screen. It's not mine. Someone has is drawing something. I don't know why this is these green lines.
Please continue. We'll take care of it. Please
Okay, I'm sorry about.
We will take care of it. Just now.
Okay, I'm sorry about that. So next, I'm going to talk about the asserted estimation, my predictions of the predictions, of the model predictions, and following the aquifer mapping, which is the target of the specific geostatistical methodology. And the talk is going to close with the concluding remarks. So, first of all, I'll try to keep about the aim and scope. I'm sorry about that. I cannot see the label for some reason, and I'll try to. Okay, regarding the aim and scope, as I was previously mentioning, I can still see these green lines. I don't know why. I don't know if it's.
Dr. Ravi, I think that somebody is using the digital board. You can.
Yeah, sir. We are just disabling that application.
Yeah, you can disable disable the digital board. Yeah.
Okay.
Sir, please continue. We will manage it just now. We'll take care of it.
Okay. So I'll continue. About aim and scope, this work has several aims and scope, and specifically and primarily, it's a combination of spatial and temporal groundwater information regarding groundwater level in order to exploit spatiotemporal correlations to be used for monitoring and prediction. Also, another aim is the development and application of novel spatiotemporal variogram models Also the application of geostatistical methods in association with auxiliary informations in order to improve space-time visualization and maximization of space-time variability. In addition, we would like to assess the applicability of space-time residual kriging method for such approaches with a complex background to assess the spatiotemporal variogram prediction efficiency for future time step predictions, and also to assess the estimation of uncertainty by using a simulation methodology in order to improve this part, which is very, very important for geostatistical applications. Now, a few words about geostatistics for those that are not familiar. Geostatistics is a set of statistical tools for the space and time analysis of physical variables. So physical variables in the environment, in any kind of physical variables that have in the space-time context. Specifically here for this work, its application in groundwater level. Geostatistics are based on the properties of random fields, like the randomness and interdependence of the variable of the physical variables at different locations. And the basic aim is the prediction of these variables at unsampled locations in space and time. So in other words, generally, the geostatistical analysis methods, either in spatial term or in space-time context, are aimed to calculate first the statistical and model parameters, and in order to perform an optimal prediction at unsampled locations in space and time. Regarding now the spatiotemporal methods, spatiotemporal methods nowadays are more popular and compared to spatial-only methods, and this is because environmental variables are distributed in space and time, and it is more desirable for us to know the dynamic behavior of the physical property that we examine. So in terms of space-time methods and in terms of geostatistical space-time methods, a basic component, a basic characteristic is the spatiotemporal dependence, the calculation of spatiotemporal dependence, the spatiotemporal interdependence between the available data. This can be occurred in the modeling with different approaches, such as calculating the space-time covariance function, also with temporal correlated fields or with spatial correlated fields. Very popular methods applied in space-time geostatistics are the family of kriging, like space-time modular kriging and space-time residual, or some they call it regression kriging, and obviously simulation methodologies. Why now? Someone going to ask why space-time geostatistics, and the answer is quite simple for me and for most of the colleagues that they apply geostatistics in similar problems like the one in groundwater. And this is because physically based models are not always appropriate to describe specific temporal variations in terms of some shortage of information, like sparse or scarce data, or not enough available information regarding the boundary conditions of the topic that it's examining, like an aquifer modeling of aquifer levels fluctuations. Also, a big advantage of space-time geostatistics is the handling of large amounts of data. They are very popular in big data handling, and nowadays we have a lot of data that come from remote sensing sources. And specifically for space-time geostatistics, and this is to end the introduction of the applicability of space-time geostatistics, some basic characteristics that I would like to highlight are first that they are popular in environmental applications because many environmental variables are distributed in space and time and not in space only. It's very easy to add to include the time dimension as a third or a fourth dimension in order to build a geostatistical model, which is now going to have a different form. The random field is called Z, and now we don't only have the S, the space, but also the time, as you can see. So instead of ZS, that actually represents the spatial field. Also, one should be cautious on the different scale of space and time, and this should be both included and considered in trend calculation and also in the fluctuations modeling using the variogram. It is also very straightforward in space-time geostatistics to approximate the trend, any trend in space and in time, by using stochastic or deterministic methods. And finally, in the variogram, the available variogram types in space-time geostatistics that they are divided in separable and non-separable categories. They are capable in order to handle, in order to consider any geometric or zonal anisotropies present in the dataset. So by having this small introduction on geostatistics, I'm moving on the developed model, or the proposed model for groundwater modeling in aquifers, as it is the title of this talk. Usually, as you can see, the first component is to we divide in geostatistics. So we can divide our observations, which is observations here are called H, as you can see, H as point T, which is the space and time term, can be decomposed in trend and also in fluctuations. So we would like to remove any trend available in the data set in order to obtain stationarity, which is a basic rule for reliable geostatistical modeling of specific environmental of any environmental variables. So in this work, we propose to apply this trend, to approximate this trend by using a term, as you can see here, a ratio that in the numerator includes the multiplication of temporal trend and a spatial trend divided in order to keep the units right by a specific characteristic temporal trend. I have included in my presentation a lot of equations, but I'm not going to go in deep, but give only the essence of the idea, and we can discuss it with anyone who is interested in another time. So the temporal thread in this proposed model is actually approximated by using an exponentially weighted moving average filter. This is to approximate all the trend in every available well where the groundwater level measurements have been taken. Regarding the spatial now trend, we apply the Tim's equation for aquifers aquifers, and this is because in the specific aquifer that we study, there is a significant amount of pumping that occurs throughout the year. So it is compared to simple to Darcy law, which is not applicable in this situation. We apply for the Tim's equation for aquifers to approximate the spatial term, and the basic characteristics of this components of the Tim's equation is the initial groundwater level before pumping, the hydraulic conductivity information of the area, the pumping rate of the wells, and the radius of influence of every well. So by having this information, even on average, in some cases, we can quantify the specific measurements, specific groundwater levels at all the locations of our aquifer in order to represent it as the trend based in terms of the pumping that occurs in the area. So by combining the exponentially weighted moving average filter for temporal trend and the Tim's equation for the spatial trend, we approximate the trend. The next target is to use the fluctuations in order to calculate the interdependence of the fluctuation at the different locations by using the appropriate space-time variogram type now. So before showing that, I would like to give the information about the space-time kriging estimator informations, not only for the estimator is the bottom part, the part that I'm now presenting with the red dot is the calculation of this experimental space-time variogram that expresses the space-time interdependence. So it's the similar equation I would like to mention. It's the same equation as in the spatial only term, but it includes also the T term here, as you can see, the time term here. So it's not fundamentally different from the spatial context the space-time calculation of interdependence. So it's simply applying the temporal frame information in the experimental variogram. And as you can see, also the estimator, it's the linear combination of the neighboring values that are going to be calculated from the correlation length parameter through the variogram calculation, multiplied by the weights that correspond to each of these neighboring value. So it's also the same estimator, but with a spatial geostatistical, as in a spatial geostatistical context, but it includes also the time part here. So by having said that, we're moving on to the most important part of space-time analysis in using geostatistics, the calculation of the interdependence of fluctuations by using the appropriate space-time variogram. So we'll have to give the information here that in space-time geostatistics, the variograms are not similar to the ones as in the spatial context. They are different functions. So they are divided in two categories. The first category is the separable models, and the second category is the non-separable models. In terms of the separable models, that means that one can combine for time and space separately common variogram functions like the exponential, like the Gaussian, like the Maten function, like the spherical function, in terms of multiplication, in terms of summation, and there are many examples of separable space-time variograms. For this work, we applied the one that has been successfully applied in many environmental works, which is called product sum variogram. And as you can see, it actually combines information for space, as you can see, for space and also for time. Okay, we have the spatial lag and the temporal lag to calculate the interdependence of our data. So for this work, we tested two variogram functions, one for space, one for time. We apply an exponential function for space for the spatial data, a Gaussian function for the spatial data, and an exponential function, a variogram function for the temporal data. And this is because, according to the literature, we found out that in the groundwater level in time approaches an exponential covariance, while in a local scale in the spatial context, groundwater is better represented by a differentiable function like the Darcy law. So by the time we're not using a physical approach, we have to represent it by using a differentiable variogram function with a specific characteristic to capture local spatial correlations in a small scale. So that is why the reason this is a basic characteristic of a Gaussian experimental Gaussian variogram. So we applied this in combination with the exponential for time inside the product sum model, and actually has presented in different applications very good results. So another choice in space-time calculation of variogram, of experimental variogram, in the fitting of experimental variogram, it's the non-separable models. One approach can be non-separable models. I would like to express this basic compact equation that express physical processes. So a very popular one is the one that is based on the diffusion equation, and it has been successfully applied in spatiotemporal geostatistical approaches in terms of groundwater pollution. So we applied also this in our work. We tested to examine its applicability, and also we would like to present our development, a covariance function that we have developed through our research along with Professor Christopoulos, a professor of geostatistics in the Technical University of Greece, and it is called Spartan covariance function. The Spartan covariance function, it's as one can see, it might look like a complex equation, but it has actually three different forms for the specific, the most major parameter. The most major parameter here, it's the eta1. Eta1 is the shape coefficient. The shape coefficient is the one that actually determines the shape of the curve, the shape of the surface of the variogram that is going to be fitted in the experimental one. So when it takes values from -2 to 2, it has this form. When it takes values equals to 2, it has this simplest form. And when it takes values greater than 2, it has a different form. So what we did after we developed it and applied in spatial geostatistics is to substitute this lag term, the H lag term, by a space-time lag term, as you can see here, in order to convert it in the space-time context. So we included both the spatial lag and correlation length, and the temporal lag and temporal correlation length in terms of a weight factor that approximates the anisotropies in terms of space and time that that are actually caused due to the difference of the time and the spatial scale. Another innovation in this work is that we actually applied in the factor eta 0, which is the one that it is included in the seal of the variogram that calculates the variance of the variogram. Sigma squared is the variance of the variogram, a physical term in order to control the variogram fitting. This physical term, it's a hydraulic conductivity, the hydraulic gradient that applies in the specific aquifer. So the hydraulic gradient. So that was a tool that, as you can see later, it worked really well. So this is the three basic parameters of the specific function. Eta 1 is the shape coefficient, and eta 0 it's a scale. It's actually partly defines the variogram seal, and also some other parameters that we're not going to go in deep at this moment. Another tool that has been used, innovative tool in this work, and it actually worked really well. Also in conjunction with the variograms, with the variogram types that we presented. It's to use not an Euclidean distance in order to connect neighboring values or sampling values. So, and this is because in the specific aquifer and in many aquifers that they might be unconfined, there are local discontinuities in terms of the presence of a small fault or fracture only in some cases, or in a different form of hydraulic conductivity. So our research showed that if instead of Euclidean distance we use the Manhattan distance, the basic difference is it doesn't follow a straight connection of the 2 points, which is the green line, the Euclidean distance, but it bypasses the it can bypass the discontinuity. It provides a more accurate predictions. It helps the model to be more effective. So the Manhattan distance is following a grid path instead of a straight line connection between the 2 points. So also this was an innovative tool. A few words now for the specific area. The study area is located in Greece, in Crete, the island of Crete, where I'm located. It's the most productive aquifer, and as you can see, we have 10 specific points monitored since 1981 to 2015, and there are specific faults in the area. That's why we prefer to apply this specific tool, as we said, about the Manhattan distance. There are 70 official wells located in the area, upping throughout the year with different schedules, but for the 10 of them, inside the cycles, we have full information about the area, and the aim is to model the dynamic behavior of groundwater level in the area and to predict in the future time frame, and to assess the predictability of our proposed model. So, quickly show you the trend of the groundwater level in the area. As you can see, since 1981, we have a direct decline in the area. Only in the past few years, we have a specific stabilization of groundwater level, and this is the general trend that is going to be removed and used for the trend function we presented previously. So this is how now the variogram fitting looks like. The full surfaces with the gray color are the theoretical variograms, the Spartan one that provide the best results, and the product sum one that provide the second, which is the second best. So you can see with the stars and the lines are the experimental variogram, and with the surface it is the fitting. So as you can see, the Spartan variogram, because it has also a sign factor inside the equation, it can capture increments and decrements. So this is a very big advantage of the specific new variogram function. And at the bottom, this is how the average temporal and the average spatial variogram looks like in terms of our available data. So by having these specific fits, we can understand that we have reliable fitting of the experimental variogram of the interdependence of the sample data by using a very reliable and a very good fitting with our model, with the Spartan model. And moving to the results now, with the cross-validation results, in order to identify if our methodology is reliable and accurate. So here, what we did is we test four different methodologies. The first one is the space-time regression kriging, meaning that we have removed the trend as we discussed before, using the Spartan variogram and the Manhattan distance metric instead of the Euclidean metric. Secondly, the product sum with the space-time regression kriging with Manhattan distance. Third, simply regression kriging with the Spartan variogram without using the Euclidean distance. And finally, the classical space-time ordinary kriging using the Spartan variogram with the Euclidean distance. As you can see from the indices, the mean absolute error and the mean absolute relative error is really small, 3.3% for the methodology that applies the Spartan variogram and the Manhattan distance, and 0.3 the mean absolute error. So it has better performance compared to the other methodologies. And also we assess two specific indices, the index of efficiency and index of agreement, that provide the reliability of our estimations. Both values, to be optimal, should be close to 1. And as you can see, our results are really close to 1, denoting a really good application of our methodology. In the bottom part, I hope you can see how it is moving. In three different plots, we present how the aquifer changes through time since 1981 to 2015 for every dry and wet year. So in the bottom, you can see how the hydraulic head is changing, the head change in the middle, and the error variation. So with this methodology, we have managed to accurately present the dynamic behavior of the aquifer for the whole available period. And the next step is to calculate the uncertainty, which is a very important part in geostatistics. So by the time we use more parameters than those included in the variogram function, we use a lot of parameters in the trend function. So now the kriging variance, the regression kriging variance, is not appropriate to express the uncertainty. So for this reason, and due to the more parameters that will be involved in the model, we decide to apply a simulation methodology in order to quantify uncertainty. And the best one that we end up was a Bayesian, the one with a Bayesian form. So what we did is to perform an unconditional simulation in order to replicate the statistical characteristics of our data set, of the fluctuations. How we did that? We did that by replicating the model statistics in terms of the covariance function calculated during the kriging process. So using the covariance function of the kriging process and a random number generator, we presented and we performed unconditional simulations. So the conditional simulation process replicates the data, the mean, the variance, and the variogram on average. Then we use the estimation of the spatial and temporal groundwater level trend to approximate the trend again with a similar way as we presented before for every simulated realization. And the next step is for every realization to calculate the space-time variogram in terms of the Spartan model, which proved to be the best one. These iterations happened 1,000 times in order to calculate the posterior distribution of the estimation and of the parameters. And then space-time regression kriging was applied in a grid of 100 times 100 in order to perform estimation in every node and give the predicted distribution. And by the time we have a CDF of this the community distribution function of our predictions, we can actually have the range of the uncertainty. So this is how a Bayesian bootstrap idea works to quantify uncertainty. In this slide, you can see some representative shapes of the space-time variograms that applied for every realization that produced during the simulation process. And at the bottom, you can see the Variogram clouds of these 1,000 iterations. And some indices now about the reliability of our estimations. The predictive distribution now during the simulation process, we have chosen two specific points to show the predictive distribution of these specific estimations. And as you can see, one is for the wet period of 2014-2015 year, which was the target year, and one for the dry period. As you can see, it's very close to fit a normal distribution in both. And this is a sign, this is an index that our process, our results are reliable. Similarly occurs also for the parameters. The parameters who have from the parameters involved in the estimation, in the model and estimation process, we chose all of the parameters. We cannot show all of them, but we chose the most important ones. The one that presents the correlation length in time frame, the correlation length in spatial frame, the shape parameter that we discussed before, which is very important for the Variogram fitting, and the W, which is the weight of the exponential weight moving angular sphere. All of them are very close to normal distribution, showing that this has a really good and reliable results. I have 2 or 3 more and I'm closing, so I hope I will be okay with time. And the final step, it's the mapping. So the target of a spatiotemporal of a geostatistical analysis that has actually 5 steps. First is the initial geostatistical analysis to identify the data properties. Second is to remove any trend in order to obtain stationarity. Third is to calculate the experimental variogram and fit the optimal spatial or spatiotemporal model. Fourth is to make a reliable prediction, and we proved here with our techniques and with our tools, we have a really reliable and prediction modeling groundwater level. And finally is the mapping and the uncertainty. So we provide the uncertainty by using a Bayesian method, and also this is the final target now, it's the mapping. So here we present the predictive distribution of the wet period of the target year 2014-2015, and you can see how the aquifer level shapes it looks like in 3 dimensions. And also in the bottom you can see the range of uncertainty, the 5% quantile community distribution function quantile and 95% community distribution function quantile. This is like the range of the specific of uncertainty. Similarly for the dry period, also in 3 dimensions, the target year with and I would like to point here that the cross validation error, it's under 3%, it's almost 3%, which is really, really small, even compared with the mode flow model that was applied by colleagues in the similar in the similar area. The error by using a physically based model was greater compared to our approach. So the successful implementation of this technique in aquifer scale, in base scale, gave us the idea, and in collaboration with Dr. Gerald Corjo from IHE Delft, to upscale this methodology. So we took all these advantages and to upscale it in the island frame. So as you can see, we actually represent we have now more than 500 collected data in 500 locations with the green triangles, as you can see here, and with the black lines, you can see all the faults and fractures in the area. This can help us to distinct the karst aquifers with the porous aquifers, so we can apply either the Manhattan or the Euclidean distance in a dynamic frame. So in order to downscale the 500 measurements that we have, we use an artificial neural network method in terms of self-organized maps in order to represent, to use every neuron to attach on this, to associate with this all the data, all the measurement data that have similar properties. And with this way, we can calculate faster and efficient the space-time variogram by using one of the models we presented before, and specifically the Spartan one. And this actually leads to a calculation of the groundwater level distribution for the target year 2014-15 for the whole island. So we assess all the information in space-time in biannual scale to make the prediction in the time window frame of one year, one period, dry period, and one in the dry period forward and the wet period forward. And according to recent work that we have done, that is not presented here, but we can tell that is that following the years 16, 17, 18, and 19, we have very, very similar results. And that means that our model has a prediction window of more than 1 year. So by simulating, by modeling with a space-time statistical model, the past information, the past dynamic behavior of the area, we can be reliable in a time window of up to 2 or 3 years for a future prediction. So finally, before the concluding remarks, in order to recap, so the basic steps of our model is to have the database of the space-time groundwater level measurements in different locations and time frames to detrain it in order to obtain a more stable fluctuations for in the interdependence analysis for the interdependence analysis in terms of space-time variogram, calculation of the physical variogram and incorporation of physical terms like the hydraulic head and the anisotropic ratio of hydraulic conductivity. Then incorporation of the Euclidean or the Manhattan distance depending on the presence or not of any discontinuities of the aquifer. So separation of trend and residuals, then cross-validation of our model by applying this technique, as you could see here for the fluctuations, and finally calculation of the acidity by using the Bayesian booster methodology. So these are the basic steps and the innovative tools that we applied in terms of the new tools that we presented before. So in order to conclude, geostatistics provide theory and methods to quantify spatial and temporal variations and uses for optimal predictions. Acidity is automatically quantified during the process, which is a valuable information to evaluate usability of the maps. Covariance information can be easily used by applying regression rigging, so we can exploit information from covariates. Geostatistics also provides methods for spatial stochastic simulation, again very useful for acidity propagation analysis, and they can be extended in space-time and to make prediction at any point in any space-time. And also they are not fundamentally different, as I presented you before, from spatial geostatistics only. And the Manhattan distance that was tested in this work helped really good in order to bypass discontinuities and represent better the behavior of groundwater level in the area. And finally, the modified Spartan model with hydraulic conductivity scaling factor and the hydraulic gradient scale factor provides optimal results. So thank you very much for your attention. This is my contact details. You can see my email and the references that were published in top journals of this work in spatial statistics, in general hydrology, in hydrology research, advances in water resources, in hydrological sciences. So this is a work that it started like 5 or 6 years ago and it evolved from a spatial only context to space-time context in a complete model. And also would like to take the opportunity to mention that along with General Kojo, every September in IHE, we present a graduate course for a short course that can be also followed online for any one of the students that are available and they would like to follow the course. And also you can follow our new project funded from Chris Albert Foundation, at this specific webpage. Thank you very much again. I'm happy to answer any question.
Thank you very much, Dr. Emmanuel Orakchis. First of all, I congratulate you for the wonderful presentation because it is a virtual conference. We cannot just have the claps of every participant. So on behalf of every participant, I congratulate you for the wonderful presentation on the geospatial modeling and from the past information of the aquifers. You are just how you are predicting the aquifer in the future trend and all. It's a wonderful information, and since it involves a lot of very good research information, probably all the participants, they may just have very detailed information on all these things. And since the time is almost half an hour, I just call upon the next speaker. The questions, if time permits, we can just take it up in the last after the last speakers. Otherwise, the organizers can just take it from the email and then pass on to the speakers so that they can.
Thank you very much.
Thank you very much.
Contact from everyone, and I will be happy to answer any question in private or in any exchange of emails. So
yeah, Yeah, that's wonderful. That's wonderful. Okay.
Thank you very much.
Thank you very much once again. So next I call upon Professor Katiyar, and I request Dr. Shalini to just give a brief introduction about the next speaker.
Thank you, Professor Emmanuel, for a very nice presentation and enlightening about the modeling of the aquifer levels using the different tools. I hope the participants would have enriched their knowledge by your presentation. And a warm welcome to Professor Dr. S.K. Katiyar. He has completed his doctorate from IIT Kanpur, and he is a member of Indian Society of Remote Sensing and Indian Society of Geomatics. Presently, he is working as a professor in the Department of Civil Engineering, Maulana Azad National Institute of Technology, Government of India. He has gained certain appreciations from Center for Artificial Intelligence and Robotics, Government of India, Defense Research and Development Organization, DRDO, and for his inputs in the GIS software development in the year 2012. He has published papers in the different national and the international journals and completed many assigned projects at the national levels. I welcome you, sir, to deliver your lecture.
Hello. Good evening to all. Am I audible?
Yes, sir, you are audible.
Thank you, Dr. Salli, for introducing me and inviting me for delivering the technical talk. So, just a minute. This Zoom is new for me. My slides are visible?
Yeah.
Yes, sir. Yeah.
Oh. Thank you. So, myself, Professor S.K. Katiyar, I am going to present the research work which has been done under my guidance, that is PhD work by one of the field engineer. He is a level 1 chief engineer, Dr. M.K. Nigam, at UP Irrigation Department. So our thought is on the river behavior. So topic of talk is remote sensing and GIS applications in the planimetric modeling of river meandering. So my lecture is organized under following talks: introduction, issues in river meandering, and role of remote sensing and GIS in the river meandering, study area input data, results and discussions, conclusions, and references. So with this first slide, I want to say that we see the river behavior in different way, that is sinusoidal wave. That is not arbitrary. If we are able to understand it, then it has got some mathematical shape. So one of the pioneer researchers, Leopold L.B. and Langevin W.B., they did a lot of work. So we have derived thought from their work they did in early 1960s. After that, using aerial photographs and field work, and our work is based on remote sensing satellite image. So let us introduce about the problem. Rivers propagate like a snake in plan. So S curve in general a meander shape, and these curves are repeating. So according to Leopold, the meandering behavior of rivers mainly depends on sediment load, discharge, and dynamics of flow. It is a very complicated thing. So many parameters are involved. So mathematical thought on the modeling of planimetric modeling of river is that we have got some amplitude, then it is a sine wave. This is the actual shape, and this is the sinusoidal planimetric geometry and its parameter. This is meandering planimetric geometry. So what has been done from satellite images, we have derived different parameters of meander based on this Julian P by 2002 and Leopold work. So first thing is why this planimetric modeling of rivers is required. We all know that rivers are behaving in erratic way. There is erosion and deposition process, and because of that, we want to do a study about sediment load, hydraulic factors, velocity, and local slope. These are the parameters which are affecting the planimetric geometry. So rivers are dynamic bodies and temporal in nature. So we do training work because of environmental changes, degradation, soil erosions. We require proper training work. So river training work requires study of river behavior. So this channelization of river is the process which was the main emphasis in the study area for the land reclamation work, because in Kanpur, river left the bank by a distance of 7 to 10 kilometers, and because of there was some issues. So if we summarize the factors affecting the geometry of river, then it is discharge, longitudinal slope, sediment load, roughness of bed, controlling structures, and other unforeseen factors. So purpose of this slide is that it is a very complex thing. It is very difficult to model all these parameters. So because of complexity, we need some simple solution. So that solution has been evolved by the use of temporal satellite images by validating the meandering parameters. So what are the issues? Since the ancient time, due to dependency on water, most of the habitations and big cities were developed on the banks of rivers. Due to urbanization, there are various issues in almost all the rivers. In river Ganga also, various issues are there. And in most of the cases, river has left the bank of city. Say in Kanpur, they have dig a channel of around 7 to 8 kilometers to bring drinking water. This is the situation. So because of that, we require some approach for studying the behavior of river so that we can plan future land use. In the river meandering geometry, modeling ground truth data collection and model validation is a difficult task. We have studied work of Leopold. They did extensive field work, then used some aerial photographs. But nowadays, because of developments in the space technology, we have images, we have got GIS platform in which we can derive the input. So we can get more accurate solution rather than their work. So that was the motivation for doing this work. Now temporal images are available on free domain, means USGS images are available. Now ISRO has also opened. Since we closed this research work in 2016, so that time ISRO images, old images were not available. So we have used the Landsat images. So in short time, you can get these data, and in GIS environment, you can derive the coordinates of different years central line by the side. So meander parameters you can derive with the help of GIS platform. So temporal change detection has been done. So these are the points for the need of study. Civilization has developed along the rivers. Cities near water bodies have noticed higher growth in population and intensive industrialization. So there is stress on land. So in Kanpur, in a study area, that was the objective of irrigation department. By the side of river bank, they want to develop the land with the help of Kanpur Development Authority. Any encroachment in natural flowing rivers need knowledge of river behavior. If we encroach the river, then we can see the devastating effects of river because of flooding. So we have to restrict ourselves beyond the river territory. So because of that, we require study of river behavior. So this is the need of study. Study area is Kanpur. Actually, this Kanpur city has been selected because of some reasons. Before Kanpur, there is one place, Bithur. It is a historical place. Their river left its course. So some more portion of bridge to be constructed because river is flowing at some other place. So that was the concern for the UP government. Another reason was that on this stage, there is one place below. After that, there are two bridges and barrage was constructed in the year 2008. After the construction of barrage, there were changes in the river course. So that was the objective, that how river is behaving after construction of barrage, what should be done for the land utilization. So actually there are some well established empirical formula on the basis of which engineers and researchers are doing their calculations. But here from actual data, we have done efforts for modeling the geometry. So these are the details of study area, and it has got 2.92 million population as per 2011 census, and it is the largest industrial city in the Uttar Pradesh, and these are the UTM coordinates. Then these are the other data. Two highways are going on by the side of river, one on the left, another on the right. So study area is below Bangarmo Bridge and Kanpur. There is one place, Bangarmo also after near Bellore. So from that stage, we have selected around 54 kilometer stage and collected different year images. So this 7 kilometer upstream of railway bridge, one barrage was constructed, and we were able to see 1.5 meander loop very clearly. So that was also a basis for selecting the study area, that at least we have one full loop and half more. So data used was Landsat satellite images at 30-meter spatial resolution, though data is available at better resolution also, but this type of study, 30-meter resolution is more than sufficient. Another reason is that USGS website is having all the continuous data for different years. So we were able to get that data from USGS website. We have used ArcGIS software, Erdas Imagine for image processing. In ArcGIS, we have determined various parameters by determining the coordinates. In Excel sheet, QGIS was also used in combination with ArcGIS, some functionality. And in Excel sheet, we did some calculations of different parameters. So these are the different year satellite images which have been used for this research work. We started from the year 1973 and ended in the March 2015. because we have to select a large data set over a period. So these were available before 73. You were not able to get images. That was also a reason. And okay, it is around more than 40-year data. So different year images have been downloaded. So these images are from MSS sensor and thematic mapper sensor. All are lands, and then OLI sensor. So methodology for planimetric modeling is that we have generated temporal maps of the central line of river as well as its boundaries, river banks. And this methodology has been implemented on the basis of one formula given by Williams. And this formula includes various parameters. I have not included those details because it is not possible to cover in half an hour. And that is also not objective of talk, because objective is to emphasize utility of remote sensing and GIS in planimetric modeling. So what we did, we have derived these parameters from temporal satellite images and validated with this formula. So this flow chart is showing various steps. First, images were downloaded, then layer stacking was done. Every year image, they have been georeferenced and staked. Then images were pre-processed to enhance visibility. Then we have cut the area of interest because the other area we have excluded, and only river portion and some more portion has been collected. And from georeference images in Universal Transverse Mercator System, UTM system, this is the coordinate system which is being used by geoinformatics community all over the world. So in International Coordinate System, UTM, we have derived the coordinates by taking false origin. Then these coordinates were used in GIS for plotting the position. And these coordinates have large values. To avoid redundancy of data, we have taken some false origin at the beginning point of river near Bellore. And with respect to that, we have calculated all the coordinates. The study area is specific. Then we have these temporal maps, we have superimposed on that and derived different parameters as given in Williams formula. Then channelization was proposed, that what will be the behavior during last more than 40 years, how river has behaved, which area can be used for the reclamation. So this is all about methodology for the work. Results. So these are the results which we have derived. Ganga River has been analyzed for temporal changes, 12 satellite images that I've already told. And average amplitude of this meander is around 3.1 kilometers in a belly length of 46 kilometers. And average sinuosity of single meander loop, this is the meandering parameter which we have derived. We have referred some other references also that I will tell you in last. So since 1953, we studied the IRI 1990 report in irrigation department report. So what is the process? These are the some of the images. These are the false color composite images which have been used. So this is the image for 1973. This is for 1988. So each year image false color composite has been generated, and 1973 year was selected as the base year for determining the changes, that how these changes are taking place. So another image is from 1996, then 2015. In between images I have not put. So these are the four representative false color composites. So here we can very clearly see the river meander behavior. So we have digitized the central line as well as sides of the river. Then these 12 different images have contributed different shapes. So this is the river central line we have plotted. So here you can see this is the railway bridge in Kanpur. This is the barrage 7 kilometers before that on upstream. Then there is another road bridge near Bithur. This is the bridge near Bangarmo and Billor. So these are the different places. Here we can see that how this river is showing its erratic behavior. And what we did, these are the coordinates. With the help of these coordinates, we have determined the shifting in terms of easting and northing coordinate. Means what is shift in 1973, east and westward shifting we have determined. So these are the shift values for the river. On the basis of this data, we have plotted all the 12 images. So in different colors, we have plotted the shape, that how this river meandering was in different years, what was the temporal behavior. Then on the basis of this, we have calculated from Williams formula that what amplitude is there. On the basis of, we have predicted that in future, what will be the firm bank, means the bank which river will not cross. We determine the river territory for land reclamation. So this is the final line on the two banks. And these are the parameters which have been determined. I will not go in detail of that, because if anybody is interested, then I can tell more, because this is the work of my PhD student, and this various parameter modeling is another mathematics thing. It is not possible to explain, but these are the results which have been derived from the satellite images. So finally, I want to conclude. These are the conclusions. River Ganga has been analyzed for temporal changes for the period of 42 years since 1970, using 12 satellite images belonging to this period. Shifting behavior of River Ganga was predominant in the study area. Third point is, after construction of barrage at Kanpur, the river has shifted in the upstream as well as downstream of barrage and created a new sinusoidal loop in the year 2000. After construction of barrage, there was new sinusoidal loop. The barrage construction proved to be helpful to bring back the river Ganga to its ritual ghats. Earlier, it left the Kanpur city, but after construction of barrage, river came near to the city. Then Ganga River has an average amplitude of around 3.1 kilometers in a valley of 46.2 kilometers. So these are the conclusions from this research work. Finally, references. These are the references we have taken from different sources. This Kanpur KDA, they did some work. Then CBIP, Then IIT Kanpur, one professor, Dr. Rajiv Sinha, he did a lot of work on river behavior. We have taken reference from that. IRI Roorkee, UP Irrigation Research Institute. Then main work was from Langevin. So this is the main work of Leopold and Langevin. And this is reference of my PhD student thesis, Dr. M.K. Nigam. So with this, I would like to stop because as per time schedule, I have to complete. So I hope that I have not crossed the time schedule limit. So thank you very much for giving attention. So if any queries,
Thank you very much, Professor Katiyar Saab.
Thank you, sir.
So you have really wonderfully, you have just done your job within the time, well within the time. It is not within the time, it is well within the time. Okay, you know very well, most of the Indian rivers, especially the major rivers like Ganges, Yamuna, Koshi, and the lower part of the Ganges and all those things, this is the major problem. When you just go for the development, it is a major problem. You have just taken a very, very important problem and you have analyzed. I know very well when rights people, they ask, they have to go for some of the bridges. I have seen in the field also, there are many bridges. It is all away from the river. River will be one place and the bridges will be the other place. So yeah, you have just taken a very important problem. And if I think Dr. Shalini, if any questions are there, we can allow them because some time is there for another 2-3 minutes.
Yes, sir.
Yes, sir. There is one question.
Yeah.
Okay, the participant has asked that for measuring of river volume, velocity, and bed load should be considered or not.
That can be considered. Actually, my starting slide I had told, but it is a very complex thing. So because of that, we have used satellite images. Let us see the fact, because that should be calculated in my beginning slide.
Yeah, you have just told the parameters. Under the parameters, what are all the parameters you have to go? You have just put one of the parameters as this one also.
Yes. So this sediment load, discharge, dynamics of flow, then parameters I had listed. These are the parameters: discharge, longitudinal slope, sediment load, roughness of bed, controlling structures. But for doing research, modeling all these parameters and relating, I have not gone because I am person of geoinformatics. So from my side, from satellite images, we have tried. So it is a very complex thing, but ideal way is that we should calculate all the parameters and each of the parameter has effect on the meandering of river. That is the different thing which can be investigated. But I have not gone for that because that is another direction for it. But these parameters should be calculated. Right. I hope that I have replied. Any further?
Yeah, thank you very much.
Yes, sir. Thank you, sir.
Okay, shall we just go to the next speaker, Dr. Shalini?
Yes, sir.
Thank you, sir.
Okay, thank you very much once again, Dr. Katiyar Saab.
Thank you, sir. Thank you.
Okay. So next paper, I just call upon Dr. Anthony Gididu. I request Dr. Shalini to just give a brief introduction of Dr. Anthony Gididu.
Yes. First of all, thanks, Professor Katia, for such a wonderful presentation and taking into consideration the case study of the river Ganga, which is, we all know that it is a very important river in aspect to India. Now, coming to the next speaker, I would like to introduce Dr. Anthony Gididu. He has completed his doctoral program in geomatics from the University of Cape Town, South Africa, and presently is an associate professor in the Department of Geomatics and Land Management at Macquarie University, Uganda. After completion of his doctoral studies, he embarked as a postdoctoral fellowship at the University of Witwatersrand in Johannesburg, South Africa. He has also been a visiting research fellow at the Plymouth Marine Laboratory in the United Kingdom, University of Virgin in Norway, and Indian Institute of Remote Sensing in Dehradun, India, where he was on a Dr. C.V. Raman Senior Research Fellowship for the African scientists. His research interests mainly cover the broad spectrum of environmental applications of remote sensing, machine learning applications in remote sensing. Welcome, Dr. Gididu.
Thank you very much. सर आपका स्क्रीन शेयरिंग स्टॉप कर दीजिए सर, कटियार सर. Katiar sir, you can stop your screen sharing so that next speaker can start sharing the screen. Okay, thank you.
Okay, thank you very much. Let me get my screen ready. All right, thank you very much. And it is a great privilege for me to be sharing the research that I've been doing with such an august audience. As you have heard, I am Anthony Gidudu from the Department of Geomatics and Land Management at Messara University, which is in Kampala, Uganda. And
excuse me, sir. Excuse me, sir.
Yes, please.
There is some echo in your sound. Are there two devices on?
No.
Okay. Okay, please carry on.
Yeah. So, yes, I had a wonderful time in this conference so far, and I'm happy to share my work with you. I just thought it would be a good idea to locate Uganda relative to India. As you can see, we are 2.5 time zones from India, and we have a shared heritage due to our colonial past. Makerere University is an old university, probably not as old as some of the universities in India, but we are the oldest university in Uganda. It's a public university. We have around 40,000 students, and we would be happy to host any of you for a visit or a research talk. Now to my presentation. Lake Victoria is a major water body in Africa, and as you can see from the map of Africa, we are located pretty much in the middle of Africa. It is the largest freshwater body in Africa, and the second largest water body in the world. And I was doing some calculation.
Dr. Anthony, your voice, people are just complaining that the voice is not clear. Can you just slightly hold the microphone close to your arm?
Is this better?
I think so.
Okay.
Yeah.
So I was doing some calculation, and I saw that if we shifted Lake Victoria to Madhya Pradesh, it would fly up almost a quarter of the landmass. So we are talking of a pretty massive landmass. And the other characteristic is that it is a transboundary lake, surrounded by Uganda to the north, Tanzania to the south, and Kenya to the east. And you can imagine, a lake this size, would support the livelihoods of so many people. If you consider the basin, Lake Victoria Basin, and the other fact is that it's the source of the River Nile. So it supports the livelihood of over 200 million people directly and indirectly.
Sorry to interrupt, Dr. Anthony. Are you using two gadgets?
I am.
Yeah, because echo is coming. We are not able to clearly hear your voice properly.
Let me try to remove.
Now echo problem is coming.
How is this?
Yeah, now it's okay.
Okay, maybe it was the headphones. Okay, so like I was saying, Lake Victoria supports avails numerous ecosystem services. There's also food, there's also potable water, agriculture, recreation, religious practices, and the list goes on. As you would imagine, this therefore means that there are many stakeholders who are vested in the quality of water in Lake Victoria. And I would like to now talk about the challenges that we have in monitoring water quality in Lake Victoria. The obvious challenge is the size. Given the size of the lake, all the monitoring techniques are very challenging. You know, it's a transboundary lake, and in spite of this, we still need to monitor its quality. Now, for all the stakeholders, when they are collecting, when they are monitoring water quality, they are deploying traditional means of observation. So you get a vessel, you go to the lake, collect your sample, come back, process the data. As you can imagine, this is expensive, time-consuming, cumbersome. Now, whereas in situ observations are accurate, they are limited in space and time. So what that means is that whereas I can get my water quality sample at a given location, that doesn't tell me what the water quality is 2 kilometers away. So in that regard, it is limited in space. And it also means that the next sample, the next idea about water quality will depend on when I next go to the lake. So that's what we mean by saying that in situ observations are limited in space and time. So it is this conglomeration of challenges that has inspired us to explore the use of Earth observation. The thing about the advantage that Earth observation gives us is that we have a series of satellites orbiting the Earth, you know, taking photographs of the Earth from space. And this is data that is regularly collected. It affords us various advantages, one of which is synoptic coverage. So, whereas with my in-situ observation, I will only get the water quality at a point, satellite imagery will give me the water quality of a broad area. Studies have shown that it provides accurate data, and the other advantage, and I think we saw this in the previous presentation, we have access to archival data, which means that as long as we know what we're looking out for, we can go back in time and we can go ahead into the future. So, satellite imagery affords us archival data, and we're also able to integrate it with other data sources. And in terms of sustainability, one of the major advantages is that we have access to imagery, which is freely available. So these are some of the motivations as to why we want to explore the use of Earth observation in monitoring water quality, in mitigating against the challenges of in-situ observations. Now, for most of us, we get into remote sensing through land cover mapping, and you know, that's the usual route that we go through. In this case, when we're looking at Earth observation for water quality monitoring, we want to go into the realm of bio-optical modeling. location, coordinates. That coordinate will enable us to collocate that coordinate satellite image, and then what can we relate? How can we relate? So the idea is, can we relate a pixel file to a given water quality parameter? That's what we essentially are into. That's what this work has been about, and such we've been doing for about 8 years so far. Now, our observation of water quality monitoring is dependent on what we refer to as color producing agents. We have constituents of water which are able to taint or to colorate the water. And it is this that is monitored from space. As a matter of fact, if you look into literature, you come across what they refer to as ocean color remote sensing. Some people refer to it as marine remote sensing. So the idea is that because these constituents alter the color of water, this is a phenomenon which we can capture from space. And at this juncture, I'd like to mention that there are parameters that are measured from space, but there are also those we cannot monitor from space. So our observation is a part solution that we are proposing. It's not a complete solution to cover everything about water quality monitoring. But for the parameters that we can measure from space, we want to build a case for our policymakers to explore and operationalize the use of our observation in monitoring water quality. And so some of the parameters that we can monitor from space include chlorophyll A, water clarity, and turbidity. Temperature is not a color-producing agent. However, there is a thermoscanner on many of our satellites, and it is that thermoscanner that enables us to measure temperature. So, coming to the parameters we can't measure from space, this includes pH, conductivity, hardness, salinity. So that is the realm of parameters that we cannot measure from space. So why are we interested in temperature?
Sir, sorry to interrupt, sir.
Yes,
but there is a lot of request that your sound is not clear, because in my opinion that you are sitting inside a hall. That's why echo sound is coming continuously. There might be problem with the earphone or the microphone, but your sound is not proper coming. It's not coming properly, sir.
Okay.
It might be the place in which we are sitting.
I'm just in a room.
So, Khan sir, I feel that the room in which Anthony
Yes,
sir
ma'am.
is sitting is hollow.
Yes, ma'am. Yes, ma'am. It might be like that it is a hollow room.
Empty.
That's why echo sound is producing inside that room only.
Yeah, the echo sound is due to that particular.
Yeah, it is the sound in the room actually, because when you drag that chair, it is coming in the echo.
Is that better?
Actually, if Dr. Anthony accepts, probably if you are able to just shift it to some other place, we can just continue in the after two or that is just before the last lecture, because we are not able to hear anything. The echo is too much. All the participants, they are just telling we are not able to hear anything. This we have not come across in any of the speakers so far.
Okay, I will look for another room.
Can you just look for it so that we will come back? We'll come back after an hour or so. After that, just before the last speaker, probably you can take up from this place, from the justification, from the where you have just stopped. From there we can continue. If it is agreeable. Okay, if it's all right.
Yeah, that's fine. That's fine.
Okay. Thank you very much. I'm sorry. kindly just you can, if you're possible, you can just shift to some other place. Because of the echo, we are not able to hear anything. So all the speakers, they are complaining that nothing is audible. Okay. So with this, we'll come back to Dr. Anthony after some time. We will just go to the next speaker, if it is agreeable.
Yes, sir. I feel that.
Yes, Dr. Shalini, we can call upon the next speaker. What is our Swati? Dr. Swati?
Yes, sir.
Yeah. So I just request Dr. Swati to talk about his topic, and kindly just keep half an hour time. I request Dr. Shalini to just give the brief introduction about Dr. Swati. And another thing also, and she's a special person for this conference, because she is the only lady or girl, whatever it is. So she is the only person available for this conference. So it is a special person. It is a special lecture also. Dr. Swati, please.
I would like to give a brief introduction, and introduction of Miss Swati Maharishi is very important for everyone to listen, as she plays an important role in our research articles and the books coming from the desk to the public domain. You will know once I give her a brief introduction. Actually, she comes from acquisition to the project management, and from development to quality control. She has worked in varied areas of academic editorial board. She is a lead of Asia Pacific Engineering and Applied Sciences books program at Springer Nature. Prior to this, she was a lead the Engineering and Applied Sciences in South Asia, including both the books and journals. Under her management, she has signed more than 450 book contracts and launched many new journals. In short, she manages the articles from the researcher's desk to coming to the public domain by maintaining the market standard and the expectations. Welcome to you, Ms. Swati.
Thank you, Dr. Shalini. And if I may, I'll start sharing my screen. And while I do that, I am actually, I must say, a little bit sad that I am the only female speaker today. Or for this entire event. Is it just for today or for the entire event?
For the entire event, but you are important as well, because you play an important role in bringing our research articles from our table to the public
because
domain.
One of my pet projects outside of my day job is actually promoting the state of women in science and engineering. So I must say I am quite sad to have no other female speakers in this program. Maybe we will remedy that next year, sir. Please get in touch with me and I can help make it a more diverse panel of speakers next year.
That is the reason I said you are a special person.
Okay, thank you very much for inviting me. And I must say that this is a special talk in that it doesn't have to do anything with the topic that you've been discussing for the past 3 days. It's more about a general topic about publishing and ethics in publishing and research. Okay, that's what I'm going to talk to you about today. I'll try to keep it within half an hour. Usually, we can talk for hours and hours about ethics. And if you have any questions, please keep posting them in the chat box. I'll try to leave about 5-6 minutes to talk about your questions at the end. All right, so let's get started. I'm going to skip my introduction. Thank you, Dr. Shalini, for introducing me. As she said, I'm currently the editorial director for the Applied Science and Engineering Books program in Asia Pacific for Springer Nature. A very, very brief intro about Springer Nature, just to let you know. I know it's been 5 years, but some people are still not aware that Springer and Nature are now one company. So we merged together in 2015, and we are now one of the largest publishers of academic books and journals in the world. And we publish across all these brands that you see on my screen here right now. And as I said, we are one of the oldest, so we have had over 175 years of experience in this domain. We are the largest open access publisher with over 600 fully open access journals as well, and a very robust open access books program. And a matter of pride for us, most Nobel laureates have published with us at some point of time or the other. And some of the most recognized names you see here, including Pavlov, Einstein, and Bohr. And now we'll dive into what research integrity is and why is it important. So research integrity is important to maintain the quality and the integrity of the work that is published. Okay, so only if the research is done with full integrity following a set of ethics, only then can the published work be relied upon by researchers like you to learn from and to take forward your research with. Okay, and one of the most important tools to maintain research integrity is peer review. What is peer review? It is a system to select which research should be brought to the attention of other researchers. It gives feedback to improve quality of research publications. It validates the results of research publications before they are published. Okay, so those of you who have published in journals or even in conference proceedings know that content goes through rigorous peer review processes before it can be published. And that is the biggest value add of publishing your work. Now I'll talk a little bit about the different kinds of peer review processes. So the most common one is the single blind, where the reviewers' identities are hidden from the authors, but the authors know, but the reviewers know who the authors are, right? And then the next most common is double blind peer review, where the reviewer doesn't know who the author is and the author doesn't know who the reviewer is. There are also some open reviews. Some journals do open reviews where all identities are known. Reviewers know who the authors are, authors know who the reviewers are. Then there is also a method of having transparent reviews, where the reviewers' names are kept anonymous, but the review comments and their responses given by the authors are actually published alongside the paper, so people can see how this paper was improved in the process of peer review and before publication. Okay, now I believe that many of the problems with research integrity or publication ethics happen because authors are in a rush to publish. I show here in this graphic on the right hand side the publishing process. Most of the time is spent in the middle and the bottom part of the process that you see, which is about peer review and revisions. Okay, these are integral to the publication process. Please leave yourselves enough time so that a good journal can spend time on reviewing and helping you revise your work. Also, peer reviewers are looking at your work objectively. They are not out to get you personally. Please take peer reviewers' comments positively and constructively. Even if they give you negative comments, use them to improve your research. That's the utility of peer review. Okay, so please don't take peer review comments personally. Also, especially for young researchers, please remember that very, very rarely are papers published without any form of revision. Okay. Typically 2 to 3 rounds of revision in a journal article are very common. In some cases, it could even be more. Okay, so please leave yourself enough time that a good journal can complete the rigorous review process and provide inputs for your paper. What is research integrity? Now, I just told you research integrity is the honesty and verifiability of methods in proposing, performing, and evaluating research. So only when research is done in an honest and ethical manner and published in an honest and ethical manner can it become reliable. Okay, so it's the reporting of research results. In the reporting of research results, you should pay particular attention to rules, regulations, guidelines, and follow commonly accepted professional codes of conduct, norms, or ethical practices. This applies to all levels of research and research publishing. So while you're doing your research, so before you publish, while you're writing, reporting, and publishing, during you publish, and after you publish. So the responsibility of research integrity doesn't go away after an article is published, okay? The responsibility still remains. And whose responsibility is it? It is everyone's responsibility, everyone who's involved in the research enterprise, which includes you as a researcher. It includes your partners or collaborators, either in the same institute, other institutes, industry, in India, US, Africa, Japan, Korea, it doesn't matter, all over the world. Ethics committees of your institute, of the journal, of the publisher, sometimes even funding agencies might have ethics committees. Any third-party service that's helping you. For example, you take the help of a third-party service to improve the English or the language structure of your paper. But that third-party service ends up copying things and putting them in your paper, which you don't know about. Whose responsibility is that, right? That's not your responsibility alone. So third-party services also are responsible. The peer reviewers are responsible for maintaining the integrity of research and the integrity of the review process. The funders are responsible to make sure that the research that they're funding is done and published in an ethical manner. The editors of the journals are responsible to make sure everything that goes on in their journal is done in an ethical and honest manner. Okay. Sometimes the funder could be the government. Sometimes the government is responsible for large institutes. So the governments are also responsible. And not last but not the least, the publishers are very much responsible for research integrity and publication integrity. Okay. I will refer often to the Committee on Publication Ethics in this presentation. The Committee of Publication Ethics is a not-for-profit association of publishers, editors, senior researchers from across the globe, and they provide lots of principles and guidelines to handle different aspects of research integrity and research and publication misconduct. We want to know more about them. They have a lot of useful stuff for authors as well. Please go to the COPE website, which is publicationethics.org. If you can't remember this, it's very easy. Search for COPE ethics on Google and you will find them. Okay. Now we'll talk about publication ethics. We will talk about all of these things here, but I will go into detail into some of the points because today we have a shorter version of this talk. And I will not go into too much detail about the other points. Okay. So all of these things that you see on the screen here are possible issues with ethical misconduct in publication. Okay, so let's look at them one by one. I will first talk about authorship disputes. Okay, authors are those people who have contributed sufficiently to the research. Okay, and that they are accountable for their part of the work and they have reviewed and approved the final manuscript. There are problems with authorship which crop up often, and most of the times the problems with authorship crop up after publication, and then it becomes an elongated process to investigate and identify the problem and find a solution to it. Some of these problems include gift authorship, such as authors who have not contributed sufficiently to the research intellectually have been included as authors. Sometimes it's ghost authorship, where authors have been excluded when they actually contributed intellectually. Sometimes there is authorship without an author's knowledge, like the name of a person was added and they don't even know that their name was added to the paper, or they don't agree that this is a paper that they want to publish. They don't think the paper is ready, but the co-authors anyway submit the paper. That's also a problem. And also there are some bigger problems with regards to papers being sold for amounts of money, or authorship, a place in the paper being sold for money to people who have actually not contributed to the paper. Okay. All of these are problematic. If you see anything like this happening, please report it. If it is happening within your institute, please report it to the management. If it is a paper which has already been published and you're aware that there might be some issues, please feel free to report it to the journal editor or the publisher. If you need more help, please check the COPE guidelines on authorship. Now, the order of authorship can be alphabetical. That's how it's preferred in some disciplines like math and economics. It can also be in the order of contribution. Typically, what we see in science publishing is that the first and last authors are usually the people who have contributed the most. So in typical terms, if you're looking at a group of PhD scholars or research scholars and their guide, the research scholar who contributed the most would be the first author, and the guide would be the last author, right? And the other people in between have contributed to varying degrees. It is important to identify who has done what and write this in the cover letter when you submit it to the journal, okay? Exactly who has contributed what, so that in case of future authorship disputes, that information can be referred to. So the authorship contribution statement is important, okay? It helps avoid future problems. And authorship disputes cannot be arbitrated by the journal editor or the publisher because they don't have access to information regarding who has contributed what during the research period. Okay, so it's usually referred back to the authors and the institutes of the authors to help resolve such issues. And any changes in authorship need to be consented to by all authors with a change of authorship form and a clear reason as to why an authorship change is required. Even if this is done before the paper is published, just after it's submitted, all of this information is required. It's a very long drawn process. So please have a clear discussion about the authorship before you submit the paper. Next thing that we come to, I think it's self-explanatory. Data fabrication and falsification is a big no-no. Please do not make up research findings. And also, please do not manipulate data by removing inconvenient or negative results, changing or adding data points, or including, this includes manipulating images. Okay, this is very important. If it is uncovered even after the paper is published, there is action that can be taken. Again, all these ethical investigations are very long drawn and involve a lot of stakeholders. So please make sure that you don't undertake any unethical activity during your research. If you need help about any of these topics, once again, I will refer you to COPE or to other senior researchers who have been working in the field. If you have a question, please talk to them, or please go and ask questions on the COPE website. Okay. Data fabrication and falsification is a big problem because it sends other researchers on the wrong track. We are working to make sure that other researchers can read and use and cite our research. So if we have incorrect data representations in published papers, researchers who are planning to build their work on that data are actually wasting their time if the data is falsified. And in medicine, it can actually delay the development of life-saving treatment, drugs, or prolong the use of ineffective or dangerous therapies if the data is manipulated. Okay. Now, coming to image manipulation, again, manipulating images has to be completely avoided. Sometimes you need to edit an image to make it more useful for the reader to see. Okay. For example, if you have, an image from a microscope, you might need to magnify it to make sure it's visible to the reader when it's published in the journal. So you should be able to mention the magnification. Anything that you feel the need to hide from others is probably not an ethical thing. Okay. So please don't manipulate images. And there is a lot of information. Again, I keep citing COPE again and again on the COPE website to what is okay to do and what is not okay to do with images. And whatever is okay to do, if you're doing it, if you're enhancing contrast, you are changing, for example, axis because they were not really visible. So you have edited the axis of your figure. Whatever you are doing, mention that you have done that. Okay, and once again, if you feel hesitant to mention what you have done, then it's probably not ethical and you should not be doing it. Okay. Another thing that's a very big no-no when it comes to publication ethics is duplicate submission or redundant publications. Both are a problem. Okay, duplicate submissions means submitting the same paper or the same study to 2 or more journals at the same time. Okay, you should submit your paper to one journal at a time, wait for them to reject the paper before you submit it to the next journal. If you are not sure about the first journal, or if you think they're taking too much time to review your paper, you can always withdraw your paper, wait for the withdrawal confirmation, and then submit it to the next journal. Okay. Redundant publications, or what we call salami slicing or salami publications, is basically one study and it's split into several parts and published in multiple journals or as multiple papers in the same journal over a course of time to increase the number of publications. This is also problematic. Results from one study should ideally be presented together and put together in a single publication. Okay. This is a problem because if you submit duplicate papers and somehow they're published, or you have used salami publishing to slice your results into small slices and publish them as multiple papers, this overemphasizes the importance of that particular study to readers. Okay, it can distort the meta-analysis done about systematic reviews and about a particular research field. Okay, and it also wastes the time of the editors and the reviewers because they're reviewing and editing and looking at these papers multiple times. Okay, and also it can land you into text recycling and possible copyright infringement issues. We will come to copyright infringement and plagiarism just now. So plagiarism has two aspects. One is the ethical aspect of plagiarism. So when someone presents the work of others as their own, this is an ethical issue. You're taking something that you did not create and you are claiming to be the creator of it. That's the ethical issue. The second issue is the ownership of intellectual property, which is a legal issue. Okay, so when you're copying content, it the copyright may belong to an entity and you're infringing upon their intellectual property rights, which is legally a problem. You can be litigated against for doing something like that. Okay, and it is also a problem. I'll give you reasons why plagiarism is such an ethical issue with publishing. One, it gives the plagiarist undeserved status and authority. You are claiming to be a creator of a work that you have really not created. So people believe that, oh, you have done this research and you have created this piece of work, but in truth, you haven't. It deprives the original author who actually created the work, who actually did the research, it deprives them of the original credit for their work. It also becomes a problem in tracing back research ideas to their origins. And again, it can distort any meta-analysis based on a field or discipline if the content is plagiarized or copied from somewhere else. Okay, and as I said, there are intellectual property issues. I will come to that. If you need guidance on intellectual property, it's available on COPE. You see the link here. Okay, now coming back to reusing content and plagiarism. Okay, now reusing content typically requires permission. Sometimes you have to reuse content. For example, you have to use an image that was already published because you need to compare that result to your own in a paper or a chapter or something. But then reusing that figure requires permissions. Just using a citation is not enough. Okay, so you need to make sure that you also get permissions depending on the permissions guidelines. In some cases, permissions may not be required. For example, if it's a particular type of open access publication, only a citation is enough. But is it that type of open access publication? Most journals are actually, or most content is actually copyrighted to someone, and you need to take permissions. Okay, refer to the reuse policies on the website of the content that you need to reuse. Also, only reuse what you absolutely need to reuse. Please don't copy text lines from here and there. I am pretty sure someone will ask me a question about what to do with review papers. When you're writing a review paper, if you're expert enough to write a review paper, you should be absorbing what you have read and writing the review in your own words. There should be no need to copy sentences as is. In some cases, you might need to quote something exactly, then put it in quotes, okay? And depending on the length of the text, you may or may not need permissions. But if you have to quote someone, put it in quotes, give the citation. So depending on the length of the quote, typically for a short quote like 20 to 30 words, you don't need permissions, but only quote when absolutely necessary. Writing a literature survey or a literature review is not an excuse to copy sentences as is. You should try to understand and absorb what you have read and write it in your own words. Okay. Now, a very good rule, I already talked about this. You have to ask yourself, whenever you have the doubt about doing something, whether it's ethical or not, ask yourself this question. If this behavior or practice were to become public knowledge, would you have any reason to feel uncomfortable or ashamed by it? If the answer is yes, or maybe, you should not do it probably. Okay. If the answer is no, you probably are still not aware. You should still go and get more information. So publication and research ethics and integrity are a very important aspect. Please make yourself aware of it. If you are not sure, seek help from other experts in your field, or seek help from COPE or other experts on publication ethics. Now, coming back to plagiarism and reuse, like I said, while referring to published work, use your own explanations. Okay, don't copy sentences as it is. Unfortunately, at least in the South Asian system and the region, it is the way we are schooled from K to 12 that sort of leads to this behavior. You're always expected to write exactly what's written in the book. But you shouldn't be doing that. And when you're doing a literature review, or you're writing a review about what other people have done or what even you have done in the past, don't copy sentences as it is. If you reuse, make sure it's clearly mentioned. What is it? Where did it come from? Use quotes for exact text usage. Give proper citations and references. Take permissions. Taking permissions is very easy for most things. All the large publishers like Springer Nature, Elsevier, or large societies like IEEE, ASCE, etc., they usually use an automated system online. You answer a few drop-down questions and you can generate the permission license right away. Okay. And ideally, you should mention the source of everything, every figure, table, and chart in your paper. Even if you have created it, mention that you have created it specifically for this paper. Okay. And use the overlap detection tools like Turnitin and Authenticate, but use them wisely. Plagiarism is not a number. Sometimes only 2% overlap would be shown in a Turnitin report, but the main result is copied from somewhere. Okay, that is really plagiarism. And sometimes it's going to be like a 40% match, but it's only phrases. To give you an example, if you write reinforced cement concrete in a paper 30 times, that's probably going to give you a 30% match. Okay, that's not plagiarism. It's just a phrase which is occurring again and again in that field. Okay. Another important problem is manipulation of the publication process. I am not going to get too deeply into it. You can read more about it because we are sort of short on time. So you can read more about it on the COPE website. And also, if you have research that can have dual uses, for example, you are developing something for, just for the sake of science, but it can be used as a weapon. And then sometimes you need to declare this to the journal you're submitting to, okay? Because some journals and publishers might have policies against publishing work that was done to weaponize technology, for example. Okay, and that's it. And mention all your publication ethics and research integrity requirements in the cover letter, that you have taken care of all of them. If you need more information, there is data available on stringer.com and nature.com. And we are done. Thank you very much. I'm happy to take some questions if time permits.
Thank you very much, Dr. Swati. It's a wonderful presentation. In fact, this is the first of its kind in one of the international seminars and the conferences. They just keep the publication as an important factor, because this is one of the most important factor for the research field to reach to the researchers. So I appreciate the organizers for giving opportunity for the listeners how the whole thing should just go for the publications and all. If any one, I think we can just take about one question, Dr. Shalini.
Yes, sir. Actually, one of the participants has inquired that does the number of authors affect on the integrity of the publication?
Absolutely not. So sometimes, if I don't know if you've seen some of these papers which come out of the big physics experiments like the CERN experiment or the LIGO experiments on gravitational waves. Sometimes these papers have hundreds of authors because all of them have intellectually contributed. There are such large sets of data that you need hundreds of experts to analyze it. So the number of authors has nothing to do with research integrity. That those authors have contributed intellectually to the paper is what's important. Okay. Any other questions? I think that's about
No, I think all the participants have appreciated for enlightening the ethics for the publication, which I feel that in the present scenario is very important for the budding scholars and the research professionals to get the research work published in a good journal. We have to follow these ethics. Thank you, Dr. Swati.
Okay,
Thank you, Dr. Shalini.
I thank Dr. Shalini for the wonderful presentation. And of course, all the research, pardon?
Subramaniam sir, yes, Dr. Swati.
Oh, sorry, Dr. Swati. Okay, I'm sorry. Because this is again, being a member of the editorial board, we also do some mistakes when you just publish or when you come for any evaluation of the paper. So that's how the correction is just done by Dr. Shalini. I'm sorry, Dr. Swati. I once again thank you very much for giving the very lucid presentation. Shall I just call upon the next speaker, Dr. Mohammed, Dr. Shalini?
Yes, sir.
Yeah. So next speaker is Dr. Mohammed. I just call upon Dr. Mohammed to just give his talk and kindly just keep 30 minutes, 25 to 30 minutes time target. I invite Dr. Mohammed, please.
Thank you very much. I'm adjusting my video.
In the meantime, I would like to give a brief introduction of Dr. Mohammed Kassar. He has completed his doctorate in applied biological sciences from the University of Ghent in Belgium, and currently a senior researcher at the Laboratory of Eremology and Combating Desertification of the Arid Zone Research Institute, Tunisia. He has contributed actively as a coordinator or a team member in the numerous joint research projects conducted by national and the international agencies like UNU, UNESCO, UNDP, etc. He has been solicited to provide consultancy and expertise for his studies or projects conducted by the national and international organizations, and has been involved in the international expertise in different foreign countries, and is also associated to several professional associations. I welcome you, Dr. Mohammed Kassar, sir.
Thank you very much. Thank you for the invitation, and particularly my friend Dr. Yadava is online. I see him. Thank you very much for your kind invitation, and thank you for all my friends, particularly in India. I have a lot of friends, and also thank you for all the participants for attending this important conference. So, as you said, my talk is about the application of remote sensing and GIS for water and land management in the arid region of Tunisia. My presentation, so it's myself, but also my colleague, Fathi Abdelli, who is my colleague at the same institute, at the same department. Just a small introduction to the country. We are a very small country in the north of Africa. For those who don't know Tunisia, so we are in the extreme north of Africa. We are in fact in the Mediterranean region, where though the country is very small, so a maximum of length is 1,000 kilometers from the extreme north to the south. So we are a very small country between two large countries, Libya and Algeria. But our climate is very variable, as you can see from this map, where this is the map of rainfall, which varies from in the extreme northwestern part of the country, where we can receive up to 1,500 millimeters per year, to less than 50 millimeters per year in the desert area. In fact, we are here in the southern part. We are working in Medellin, where our climate is really arid, so it's around 100 and 200 millimeters of average annual rainfall. This is in fact, this is you can see here the climate region, where this is the humid or subhumid areas, arid, semi-arid. This is the subhumid, semi-arid, and then we have the arid, and then the Saharan climate in the extreme part of the country. So as you said, as I told you, so we are working mainly in this typical arid environment, where we receive, as I told you, less than 200 millimeters annually. So so in fact, as our institute is interested more in the arid areas, but also working mainly on combating desertification. So the country, so we have, this is our national action plan, where we subdivided our country in what we call it agro socioeconomic zones, where in each zone we have some particular processes of desertification and land degradation. So in the southern part, so we have, and then you can see that most of the country, in fact, is affected by the problem of desertification, even the areas where we have more rain. So we have most of the country is affected by desertification. And then in our particular region, so we have more problems, mainly related in the mountain area, related to water erosion, but in the plain and then in the vast areas, so we have more wind erosion, soil salinization. These are the main land degradation processes. These are, so within within our national strategy for climate change adaptation. So we have the Minister of Agriculture made some particular study on the climate change projection, because we are a Mediterranean country, and then it's evident that we are among the countries that will be affected mainly by the climate change negative impacts. The first evident one is the increase in temperature. So these are the projection for 2020. So I mean 2020 to 2030 to 2050, where you can see that we can have up to more than 2 degrees to 3 degrees almost increase in temperature. But in the meantime, we'll have a decrease in rainfall, unfortunately. So there are combined effects. So where the decrease in rainfall, annual rainfall, it can go up to this is a decrease up to 30%, less than 30%, particularly in the southern part of the country. So we have a combined effect of temperature increase and rainfall decrease, and then you can imagine. So we have both negative effects. As we are a Mediterranean, but also an arid country, so our water sources are very limited. So, and then within this climate change projection, and then we can see that all our resources will be almost decreased. The resources storage in the dams, in the surface aquifer, in the deep aquifer. The only thing that will increase is the increase in treated wastewater, because we'll be, in fact, we'll be consuming more water, but we'll be trying to increase the treatment of wastewater. We are now going to desalination. In fact, we started with the desalination of brackish water, but for the last 2 or 3 years, we started the desalination of seawater, and then we have now a lot of plants under construction for the desalination of the water. And then one of the desalination plant, which will provide around 100,000 cubic meter per day, is, by the way, is constructed by an Indian enterprise. And then we have, as you see, the general trend. So we'll have a trend in the decrease of the resources. Meanwhile, unfortunately, we have almost, for that reason, we have gone for the desalination. So we are almost used this is the rate of the water resources used. We are more than 80% of the use of our natural resources. For that reason, so the water resources are very important, and the management of the water resources are very important. This is an aspect. And then the second aspect of these resources, that they're spatially variable and then distributed variably, which for that reason we can make recourse to geomatics. All the spatial tools are very important, because also of the extension of the area where we are working. I'll be, in fact, I will not go a lot in details for this particular cases. I will be presenting two applications that we have undertaken in our institute, but as many colleagues know, that we are working on many aspects related to the use of geomatics in the management of the natural resources in the dry areas. I think one of the colleagues yesterday, he talked about rangelands, Mr. Bajil Sifi. And today I'll be addressing two particular aspects. One on olive trees, because we are a Mediterranean country where we produce, the olive tree is the symbol of the Mediterranean, and also it's a symbol of the country. And then a second case of application is the use of hydro modeling using GIS in watershed management, and particularly on the soil and water conservation issues and water harvesting in the dry areas. For the first case is the modeling vulnerability of olive plantation to climate change using in a GIS environment. As I told you, the olive tree is a very important one in the country, because we are a Mediterranean, we are in a Mediterranean climate, and then we are almost 10 million people, but we have around 70 million trees. So each Tunisian almost owns 7 or 10 olive trees. So it's a very important sector, and Tunisia is among the exporter of olive oil. I think we are ranked second after the European Union for exporting olive oil. But we have as I told you, the combined effect of, we are already in a dry environment, but with the complication that it will be impacted because of the climate change, with the increase in temperature and decrease in climate change in rainfall. So we'll have less available water for these trees, and then these trees are conducted mainly in rainfall. So they depend mainly of the climate and then of the annual rainfall. But in the meantime, we have a lot of extension, especially in the southern part of this plantation, at the expense of rangelands. And our objective here is to provide some, let's say, like advice or decision-making tool for the government, and then also even for the farmer, to be aware of the risks related to climate change, and then so to have more optimum extension of the growing area of olive trees. In fact, this is our methodology is based mainly is a simple water balance based model where we compared the actual or the potential needs of the olive with the available water in different situations, taking into account the impact, as I told you, of the climate change. So we have, in fact, make use of the available data on temperature, the maximum temperature for determining the reference evapotranspiration, and then using the SCA value of the olive trees. And then we have made use also of the available soil maps where we have the texture and the depth, and then we can determine the available or the maximum or the potential available soil water for the trees. In fact, we have also used the topography because we have some difference between the mountain area and the plain, because in the mountain area we have an additional water coming from the runoff, what we call it locally water harvesting, which means that the trees they can benefit from the direct rain, but also they can benefit from an additional water coming from the runoff. And then these are the topography, and then the rain map where we can estimate the runoff volume. So we compare it to the actual or the potential evapotranspiration. And then we try to compare the current olive land use map, which also we prepared with the olive cropping suitability map, and then in addition with the climate change scenario, and then to determine what we call it the vulnerability map for the cropping of olive trees. So as I told you, this is an example of the we're working in the governorate of Medellin in the southern part of the country. So we combine all these information in a GIS environment, in ArcGIS, in fact, environment, and then we produced some maps for these are what we call them the suitability for olive growing for different situations. This is like the reference situation. This is the reference for the projection of the climate change, the 20s, 30s, but also this one, and then in green is the projection for the 2050, where we'll have a lot of, as I told you, a decrease in rainfall and an increase in temperature. And then you can see that, so for the current situation, in fact, we have an important percentage of the olives where they are, which let's say they are grown in optimum conditions, but this one will be decreased dramatically, and then it will move to average, and then even may become marginal because of the climate change impacts. And then this is unfortunately it will be happening, and then we have to pay attention for this extension of olive growing areas where we may risk having trees desiccated because of the extension of drought periods, and then we can lose maybe a lot of trees because of the non-availability of water resources. And then we have, in fact, produced maps where we can, in fact, and then the decision maker, they like more maps than figures because it's more explanatory, and then we can explain where the areas that we need to avoid, in fact, the use of or the extension of the growing areas. This is a map of 2010 or the reference situation. This is the map of 2020 or 30, where in fact we have here, in fact, in the mountain is more suitable because as I mentioned, meanwhile, that in the mountains, we have the advantage of having this additional runoff water, which means that the trees, they are in better condition because they have more availability of water because of runoff. But in the plain, it's very risky, and then so we have to be very careful about especially this extension of olive trees plantation. And then in 2050, the situation will be maybe more difficult, and then we have to take into account that potential evolution in the future. And we are in fact continuing to work on this, working on this aspect. And then we have a new project where we are now on the we have a platform under the development where it will be more interactive, which means and then it's more where we have more automatic access to this platform, and then we can at any site in this area, so we can determine what is the status of the trees, and then if we need. In fact, during prolonged drought periods, the government provides some subsidies for what we call it supplemental irrigation or safeguarding irrigation. In fact, to safeguard the trees to cope with the prolonged drought. Yeah, this is the first application. The second application is an application on the hydro-GIS for watershed management in the arid region of Tunisia, and then this is a work that we conducted by our team, particularly my colleague Abdelli Fathi, where we used, in fact, the SWOT model. This is a model that is developed by the IRS in Texas, in Temple. This is a GIS-based model. For that reason, we use it, and then it's now widely used worldwide by many researchers, especially hydrologists, for issues related to the watershed management. And then it has also the advantage that it's a free software model, and then also even the model itself, the codes are accessible, which means that even you can manipulate the codes, which means that if you need to adapt some equations or to adapt any part of the model, you can do it yourself. And then the context that we conducted this work is we have a vast program, and then I see some Tunisian, I think they're online, where the country has developed, in fact, started implementing a large or vast program on soil and water conservation in the country since the independence in the 50s and the 60s. And then this program, they continue up to now, where we made a lot of work on soil and water conservation along all over the country, from the north to the south. And then also we have a parallel program on water resources mobilization, which means that the country, so we are trying to mobilize as maximum as possible of our resources, especially surface water sources. And then in the southern part of the country, we have some practices or special practices. We call them water harvesting practices, which are developed since the antiquity. And then we are trying to optimize the use of water resources at the level of the watershed. And then, as I told you, we use the SWOT model, which is also linked to the ArcGIS, but also it can be linked to QGIS, all these GIS softwares. And then you make use of the digital elevation model, the land cover map, the soil map, and then the climate data. These are the main input for the model. And then if you have observed discharge data, you can make calibration and validation of the model. And then once the model is calibrated and then validated, you can go to the evaluation of the best management practices or different scenarios of management of the watershed. This is the model where we have all the processes, because it's a physically based model, and also it's semi-distributed. So we have all the processes of the water cycle, at the level of the watershed, from the precipitation to the infiltration, and then transmission losses, surface runoff at the level of the reaches, to the percolation, to the groundwater, and then so we have almost all the processes related to the paths of water at the level of the watershed are simulated within this model. So we made use of the available topography, the SRTM, especially digital elevation model. For the land use, in fact, we made recourse to the Landsat and then spot images. And then for the soil and groundwater aquifer, also runoff, we had some data provided by the Ministry of Agriculture. For the climate, so we have our National Meteor Center, but also we have some data available on the global databases. So in fact, the model, this is in red, these are the processes simulated by the model, because the model, it has the problem that, it's not a problem, but yeah, this is the model is working like this, is when it generates runoff, it is sent directly to the reach, which is not really our case, because our case, we are using this water for, we call it water harvesting, for providing plants with this additional water. For that reason, we changed the codes of the model. This is an adaptation of the model. And then, as I told you, this is one advantage of the model, that you can change the codes. And then, so we provide it as if it's an artificial irrigation of the within the model of the to represent the runoff use or exploitation in the dry areas. So we'll call it, these are the parameters in the flow fraction, which means that how much you send back to the watershed, and then the div max, which is the how high. So you have the height of the water at these fields. So we made this sensitivity analysis, which is the case of all models that you have to undertake. First is to make sensitivity analysis to see what are the most important parameters that they affect your results when you compare them to the observed data of your watershed. So in fact, we made two cases application. One is where we have the priority for the production and recharge. And then you see here the different scenarios. These are the component of the water balance at the level of the watershed, where this is, in fact, it's like the scenario where the watershed is not treated, it's natural. So you can see these are the evapotranspiration. The water, half of the water is going to evapotranspiration, and then we have almost 20% for outflow, where we have low treatment. So the water is going more to 80% of the water going to evapotranspiration. Or when we make some more intense treatment, so we have 82%, and then for the outflow, we see that it's reduced almost to 3%, and then when you have intense treatment, so it's almost reduced at 0, which means that all the water is used inside the watershed. This is the model. It can give you all the possibilities of making scenarios for the treatment of the watershed. We have another one, because the first watershed, this one is ending to the sea, exactly. The exit is into the Mediterranean, while for the second case is not the case. It's a watershed where the water coming from runoff is used for the irrigation of trees in the downstream part, using a spreading dam. So for that reason, so we have here, this is natural, is similar scenarios, low treatment, intense treatment. So we have the distribution of the component of the water balance at the watershed, and then you see the flow out, which is the runoff. So it's reduced from 14 to 40, but But this is that you deprive the downstream user from a lot quantities of water. And then what we're recommending is to reduce the retention of the flow, and then to avoid, to allow the downstream user to make use of the runoff water. So these are just two applications of the GIS in the dry environment. And I really thank you for your kind attention. Thank you very much again for the invitation, and thanks for listening. Thank you.
Thank you very much, Dr. Mohammad Qusair, for exactly completing your talk within the time limits. And it's a wonderful presentation. Dr. Shalini, if there is any question, we can take one or two.
Yes, sir. Actually, one of the participants has inquired about the methodology which is being used.
In which part?
This he hasn't mentioned. He has just asked that which methodology have you used in your...
Yes, in the first part, we, as I said, it's a simple water balance equation where you compare the requirement of the olive trees with the available water, and then you see the difference. It's a ratio, in fact, between the available and then the potential, and the available to the potential. And then we call it, it's like a stress index. And then for the second part, so we simply use the SWOT model, Soil Water Assessment Tool model, which is available on the net. And then it's easy to download and then to use, because it's linked to the GIS, either ArcGIS or QGIS. It's an extension of both GIS models, but it's a hydrological model, and then just you need to provide inputs and then have the output after running the model.
Okay, thank you very much for your lucid presentation. It's a wonderful this thing. If any other participants, if they have some other questions, they can, the organizers, they'll just provide the email. You can just contact the speakers directly. So once again, I thank Dr. Mohammad Qusair. So now I just call upon Dr. Ram Karan Singh. I request Dr. Shalini to just give a small introduction about Dr. Ram Karan Singh. Dr. Ram Karan Singh, please.
Actually, sir, I'm not able to see Dr. Ram Karan Singh, sir. I would, anyways, I would. Yes, Ravi, sir. Has he joined?
He's there.
Yes, ma'am, he's here, sir.
Okay, okay. Okay.
Yeah,
I would like to give a brief introduction. He has completed his doctorate in the area of hydraulics and water resources engineering from a premier institute in India, then awarded by Japan Society for the Promotion of Science postdoctoral fellowship, Japanese government. He is also presently a senior professor in civil engineering, water resources and environmental engineering in the Department of Civil and Environmental Engineering in the North Cap University, also holding the position of Dean Research Development and Industrializing, Dean PhD Studies, Chairman of the International Relations Office and the Nodal Officer of the AIU at North Cape University. Besides that, he has also been awarded by the Glory of India Award, Gold Medal, Bharat Jyoti Award, Center of Excellence and Shiksha Ratna Award. Besides, he has also completed the research projects which is funded by CTZ Germany, JSPS Japan, DAD Germany, UNESCO, New Delhi, SNV Netherlands, DST and AICT in India. Many more contributions goes to his credit in the area of research at national and international level in the form of contribution of research papers as a member, a designated member of various societies, and so many more contributions. Words are less to express to define his contribution. So now I would like to invite Dr. Ramkaran Singh sir.
Yeah, Dr. Shalini, thank you. First, let me make sure that I am audible to all of you. Can you hear me properly?
Yes, sir, you are audible.
Thank you. Thank you for good introduction, and I'm very happy to be part of this international workshop and seeing the so many delegates all over the globe. And I'm more happy because I have been in all these places from where all these presentations are going on. And the previous presentation, which was given by Dr. Muhammad from Tunisia, since I was there and worked in the Mediterranean regions, so I can understand very well the olive problems. And olive quality of the Tunisia is considered to be the best quality globally. So diebacks and then sort of presentation which he gave, I appreciate. And I was there in the Omar Mukhtar University in Libya for quite some time, and a lot of friends from Tunisia. So I can understand these regions. My presentation is going to be also in the problems related to the arid regions. And this problem is from the Kingdom of Saudi Arabia. Saudi Arabia being a country of arid regions, the challenges related to the natural resources are there. And especially the water, environment, and the land resources are very precious in the arid regions. So in this study, which I am going to present in next 30 minutes or so, is related to the RS and GIS modeling based prediction of diebacks of junipers, Procera in Al Suda Highlands area of Kingdom of Saudi Arabia. So this is a particular type of plant species which is found in the Al Suda area, which is located in the southern region of Kingdom of Saudi Arabia. So southern province and very much close to the city Abha. And this study is important because this area is considered to be a tourism spot of the Arab region. Rather, it is also called as a capital of Arab regions for the tourism purposes. So this study was funded by the government of Kingdom of Saudi Arabia, Ministry of Higher Education in year 2017. And my research team was the combination of scientists, and purely biologists, engineers, as well as the people who are expert in the area of RS and GIS technologies. So in my presentation, the points which I'm going to cover is the general description of the problem, and then something about the study area, and then the research methodology being followed, and then the remote sensing data processings, findings and the data analysis, and followed by the recommendation and conclusion, and then finally the acknowledgement. So because these problems are based on the project-based activities, and all the projects which we did also got the milestone of publishing the research papers in the high reputed journals in order to complete those project activities. So it was a challenge not only completing the project as such, but also making a research publication in these areas. So I have taken one small study, but it is not limited to this. So if I talk about the study area.
Excuse me, sir. You can slide presentation mode.
Say again.
You can start the slide presentation, slideshow.
Okay, that will be fantastic. So let me go in the slide presentation mode.
Okay.
So yeah. So the study was conducted in Al Suda area in Asir region, which is in the southwestern highlands of the Kingdom of Saudi Arabia, and which is an important tourist spot with the richest plant biodiversity in Asir region. The study site is elongated in a shape and dissected. Dissected. The satellite image of land site depicted in AFCC in order to observe the features clearly. Site was delineated based on the topography and maximum stock density in juniper trees. It is located between the latitude and the longitude of 18 degree 27 minutes and 32 seconds, and the longitude of 42 degree 18 minutes and 0.559 seconds. So to be very make it more clear, this area is located very close to the Red Sea area, and since the altitude of this area is a very high, which is in the range of 2400 to 3000 meters from the mean sea level, so this area got a very peculiar type of climatic and the weather conditions. This is the only region in Saudi Arabia which has a temperature variation between 10 to 15 degrees Celsius or so throughout the year. And you can see the green vegetation in this area. That is the region. This area being has become a very important tourist spot. So the study which we took is for the juniper plants, and we saw the diebacks of these plants in those areas, which is spread nearly 291 square kilometer, covering the mountainous region in that area. So this study area is typically you can see, which is very close to the Red Sea and located in the southern region of the Kingdom of Saudi Arabia. This is also a very bordering area of the Yemen area, which is also a oil-rich area, having a lot of oil wells in that area. And if you see the typical figures or the pictures in this area, sometime in the evening, this kind of the picture you can see from the Red Sea close vicinity. This kind of the you can see the clouds are being covered in the mountainous regions, and but the typical plantation which we carried out the studies, something looks like this, like a dense forest of juniper plants. So the study was carried out to see why this dieback phenomena is there. And initially we made a lot of hypotheses what may be the actual region. And when we carried out the actual study, then we gave very good recommendations, which are also being taken as a government policies there to carry out the retry those trees and make this area green. So the policy issues which has come out of this research activity is very much useful for the government to bring out the policy in this region to avoid the diebacks of those trees. So these are the typical look of those trees. Some pictures are mentioned over here. And not only that, we also did a lot of further study related to the data collection of soils and then nutrients level in the soil, and so many other things. So sample collections and then GIS and RS based technology analysis, as well as lot of experimental setups in the labs to check the soil quality and the nutrient level in the soil, which may also have the nexus in the diebacks. So this kind of the study is being carried out. And remote sensing data processing was done with the satellite Landsat data, which was being procured by the NASA sites. And some of our research colleagues are also the member of NASA sites. So we took the satellite image data for the modeling and the simulation, as well as the study purpose. So actually some of the research papers which are published in this area in the Nature, Springer, or in the ecology journals will give the clear idea and the clear picture about these studies. NDVI is one of the band ratio that are highly correlated with the vegetation parameter, such as the green leaf biomass and the green leaf area. It quantifies the vegetation by measuring the difference between the near infrared, which vegetation strongly reflects, and the red light, which vegetation absorbs. and it ranges between -1 to +1, and this following formula is being used to get. But these things we carried out on a larger spatial scales to show how these values changes throughout the study area, which is in the large area of 291 square kilometer. We had also the projects which are being carried out at a national level and the regional scale level, which are further linked with the various other projects which we carried out in the past. So this analysis of NDVI data is from 1988, 1993, 1998, year 2000 and 2016. So here we can see these NDVI analysis are given on a spatial scale for these years for the Juniper class. And you can see these values ranges from the minimum of 0.08 to maximum of 0.693, and a mean value of 0.364, and the standard deviation of 0.086. We also use the statistical tools to get the correlations between the various parameters which we hypothesized at the beginning of the research activities. The research activities was the combination of the field visit, field data collections, and lab analysis, and then the modeling on the GIS and RS platforms, and then coming out with the analysis and then reporting in the research journals. So this is one sample typical picture I'm showing, but there are a number of such diagrams which are reported in the research papers and the technical reports which we wrote at the later stage. Slope aspect calculation is being also carried out because this was also a very important factor, because this area being having a very high altitude and hilly regions, we were expecting on which particular slope the diebacks activities are more, which we observed along the east and west facing. So this aspect ratio is calculated using the digital elevation model DEM, and so this particular diagram is being plotted and depicted over here. But here I am showing just one sample calculations, but there are a number of such diagrams which are being plotted. So if we with this analysis we go for the conclusion and recommendation, then the extent and severity of dieback was quantified among Juniper Procera natural stands in Al Suda area, Ashir area, which is the first reported in the early 1980s. And most of the trees have shown symptoms of dieback. However, they were not seriously affected and showed recovery signs. The effect of the slope aspect was evident in the severity of the dieback, and the greenness of the vegetation is detected by the NDVI data. And the best facing slope were higher in the NDVI values, green vegetation, than the east facing slopes, which may be due to the higher precipitation in the best facing slopes in the southern western monsoon. So while we did analysis, we also procured the data from the meteorological department of the Asir regions, which was for the annual precipitations, and then the sunshine hours, then the wind velocity, and there is a lot of clouds activities. So all those meteorological data we also procured from the Asir region of the Ministry of Higher Education, Department of Agriculture, and use those data in the analysis. But just for the information's sake, this particular region got the highest precipitation, around 350 millimeter per year, and that is the region and a very peculiar kind of a weather phenomena. That is the region this kind of the vegetation is being found in this area. The tree recoveries, new regeneration, and the absence of dieback in the plantation plots, in spite of the warming trends and the variable rainfall, may indicate that the climate change is not the prime cause of the dieback. So we also make a hypothesis that the climate change issue may be the major cause of major region for the dieback, but this was not so. Phenomena in the southwestern highlands of the KSA. So the climate change issue is not a major cause of diebacks, but we concluded many other regions which are the major cause, and then the government policies should take and implement to reduce this kind of the dieback of the juniper plants. The result indicate the importance of the annual rainfall in the general health and the greenness of the trees. And further studies are needed to quantify differences in the rainfall between east and west facing slopes and elevation effect of the nursing trees in enhancing natural regeneration of Juniper procera plants. So actually, there are certain experimentation sites also where the artificial plantation is being done, and then the natural vegetation which grows by itself, and then the dieback areas. All these three kind of the comparisons are also being made to find out the actual regions. It is recommended that the plantation efforts should continue, especially among trees within the natural stand, to benefit from the nursing effect. So certain trees also give the nursing effect to the surrounding trees. So government policy should also adopt the artificial plantation of those trees in order to have that area remain significantly green for the tourism purposes. So this is all about this study, though this study is a very large, and because of the time constraint, I will not go much deeper, but I shall be happy to share the certain research publications and the other research details for the researcher, students, and the research community who may be interested doing this kind of the study for the future, in the especially in the area for the arid regions. So if we draw the analogy, the state like Rajasthan, where that is also arid region, this kind of the study can have a be extended in the modeling processes because of the system analogy between two studies. So this may be a useful clue for the researchers who are working in the arid region areas. And this is the small presentation from the project. So I wish to extend and acknowledge the project grant number P42438, which was provided by the King Khalid University from the Dean of Scientific Research. But the funding is also being done by directly from the Ministry of Higher Education as well as the Ministry of Environment and Agriculture for this kind of the study. Still, we have certain live projects which are going on, and Professor VP Singh, who is the president of our society, is also a research mentor for us, and he is also involved as a consultant in some of our research projects which are still going on in a range of 1.6 million US dollar or so, in this kind of the range. We have the research project on which we are working with. This activity, especially I was the PI while I carried out this study, followed by Dr. Javed Malik, co-PI, and Dr. Isham, co-PI. And then also technical staff, Mr. Rohan Abad, and the project was completed in 2018. So thank you for giving me this opportunity and listening me. I shall be very happy to take the questions on this research if the time permits. And thank you, Dr. Salini. Thank you, Dr. Subramaniam, for giving me this opportunity to talk. Thank you so much.
Yeah. Thank you, Dr. Ramkaran Singh, for your very excellent presentation. So you are completely focused on how the arid land can be just put into use. And also you have given a very good information about how the arid land, which was as a wasteland, it has just become a useful land. So the entire thing, it was given in a very, very, very lucid way. So with this, once again, I thank you very much. And I request Dr. Shalini to take up one or two questions. 2 questions maximum.
Dr. Shalini, you are not audible.
You are unmute your mic.
Yeah.
Thank you, sir, for such a wonderful presentation and enlightening about the how to use the barren lands. One of the question is how different variables are given weights and ranks. Do these weights and ranks change according to the terrain?
This is a very good question, Dr. Shalini. While for calculating any kind of index, the weighting parameters are being done. That is the reason we need to have the climatic data as well as the data related to the natural resources such as soil quality, and nutrient content in the soil. So while we carried out this study, we gave the more and more wastage to the precipitation, which normally affects the vegetation in those areas. And precipitation is concentrated during the evening time. Every day you will find cloudy at that area. And we found that those areas which are directly coming under the way of precipitations are more green. So like north and south hilly slopes aspect was more green compared to east and west. And like that, other parameters which we hypothesize also we give the weight, and then the soil nutrient and this kind of the soil moisture, and then the climatic factors such as sunshine hours, wind velocity, all these things have been weighted. But the precipitation was the main parameter for which the highest weight was given. Thank you.
Thank you, sir. Thank you for your.
Dr. Shalini, if Dr. Anthony Jiddu is there, we can just give him about 15-20 minutes because.
Yes, sir.
Because we just started about 15 minutes late, and we just try to cover it with that one.
I'll just find out. I'm not able to see him, sir, actually.
He's available.
Yeah.
He's online.
He's there. Dr. Anthony, I would like to invite you again.
Is this better?
RK Singh sir, can you can stop sharing now so that another speaker can share.
Yeah. Thank you, sir. Yeah.
Thank you, sir.
Yeah. It is done, sir?
No,
Not yet.
So I will do, sir, from my side. If you.
Yeah. I think I don't have access. Yeah, I think.
Okay.
Yes, sir. I have done, sir.
Sorry, sir. Sorry.
No issue, sir. No issue. Thank you, sir. Thank you, sir.
Okay, thank you very much, and sincere apologies for that. I hope this is clearer. Is this better than before?
Yeah, Dr. Anthony?
Yes, please.
Yeah, please go ahead.
Okay, I was just confirming that this is clear.
I think, sir, we can skip the slides which had already been taken. We can continue from the justification slide.
Okay, yeah, so I was justifying why we are measuring these water quality parameters, and temperature is important for various reasons as listed here. For modeling, hydrological modeling, and ecological, and also ecological variables. It also helps us with to mark surface water temperature fronts. And if you are into fisheries, you're interested in upwelling, regions of upwelling, and temperature is an important factor. And sea surface temperature is also important because it gives an indication of electrobiological and chemical activity. Chlorophyll A, which would be of interest to many of us, is a photosynthetic pigment found in phytoplankton, and therefore measuring chlorophyll A gives a measure of phytoplankton, and hence the productivity of the lake as measured by trophic status. And then water clarity or turbidity gives us general indication of the lake's health. So what is the challenge that we have? The challenge is that for us to derive these water quality parameters from satellite imagery, we depend on algorithms. And the challenge that we have is that most of these algorithms have been developed for the ocean surface. And what we want to establish is if we can transfer these algorithms from the applications in the lake to inland, from the applications in the ocean to inland lakes. And maybe to give a bit of context why this is important, if we don't use the correct algorithms, we'll be making the wrong conclusions. I don't know what the situation is in India or other parts of the world, but in Uganda, because of COVID, many places we go to, they'll take a measurement of our temperature. And so the gadget has a sort of thermoscanner, which depending on the calibration gives you your temperature. And it's not unusual to have different temperature measurements depending on where you go. So translating that idea here, we want to make sure that the calibrations that we have are appropriate for our lake conditions. Because ultimately, we would like to deploy the use of Earth observation in monitoring water quality for Lake Victoria and other inland lakes. So that is the gist of the matter. That is at the heart of what we want to explore. That's where we want to go. And so what we have been doing initially has been sort of comparing in-situ observations with satellite-derived parameters. And as I've mentioned, we have looked at temperature, and for temperature, we usually use a temperature gauge. For chlorophyll A, we take observations, take samples, we process them on the vessel, and then we do further processing in the lab. We have also measured water clarity. You can see that lady at the bottom there. She is holding what in limnology they call a second disk. So the idea is that we want to lower that second disk until it disappears. And the depth at which it disappears is referred to as second depth. And it is a very important parameter for water quality measurement. We also have been looking at in-situ reflectances so that ultimately we can develop algorithms which are appropriate to Lake Victoria. And this is sort of a collage of the nature of activities that we have when we are out on excursions. You go to the lake, you measure your coordinates, and you use that information to collocate that location with where you're taking your image. You measure your second depth, get a Van Don sampler, which you use to get samples from the lake. And with that, you measure temperature. We do on-board filtering and keep the filtering for further processing in the labs. So a typical workflow involves going to a given location of interest, and because we are using modest imagery, which has a spatial resolution of 1 kilometer, we try to make sure that we are 1 kilometer away from the shoreline, and each sampling point is at least 2 kilometers from each other. And so when you get to a location, you measure your coordinates, you measure your temperature, measure your second depth, collect your water sample, do onboard filtering, and then store the filter paper for further processing in the lab. Ideally, you would want to collect your sample at the time the satellite is passing. Now, that is the ideal situation. For many people working in this area, you will appreciate that this is very daunting, it's very challenging. You spend a lot of money, go for excursions. And so from literature, we have seen that we can collect samples 3 hours before and 3 hours after. There is even literature which says you can use your in-situ data for imagery a day before, a day or two before, or a day or two after. The idea is that if you measure the temperature at the time of satellite overpass, chances are that the temperature would not change significantly within 3 hours, or the chlorophyll A, or the secondary. So
Dr. Anthony, can you just put your microphone close to your mouth?
Okay.
Yeah.
Is this close enough?
Yeah, please go ahead.
Yeah. So that is the rationale behind collecting samples within a time span of 3 hours before and 3 hours after.
Thoda.
And how do we determine when the satellite is going to pass? There is a website which can give us the details of when the satellite is going to pass. Now, many of you who have worked in remote sensing, you may be wondering why we use MODIS imagery. MODIS affords us numerous advantages. For starters, it has a very, very wide swath. If you look at your Landsat, your swath is around 80 kilometers, which would not cover the whole lake. So MODIS gives us a swath which enables us to cover the whole lake at one time, most of the time. The other advantage is that it has a temporal resolution of 1 day. So every day you can expect to get a MODIS image of the lake. And this is very important when you are going for excursions to the lake, like for 2, 3, 4, 5 days. At least you can be sure that all factors constant, you will be able to have an image for every day that you have collected data. And the other factor is that MODIS has a very high radiometric resolution, and this is especially important for water bodies where the reflectors, the reflectors from water is much less than the reflectors from land, which we're more accustomed to. So it is able to tease out these variations. So this is the typical workflow that you'd expect when we go to collect these water samples. And as I've mentioned, we wanted to compare our in-situ observations with satellite-derived parameters. So for temperature, we use the product, the temperature product, which is based on the NASA standard algorithm for computing sea surface temperature. And I want to emphasize, you can see that it says sea surface temperature. And this is because a lot of these algorithms, as I mentioned before, are typically made for the oceans. And so we're trying to they can work on inland lakes. For chlorophyll A, we're using a MODIS standard ocean current index algorithm. And this algorithm gives the near surface concentration of chlorophyll A. So sometimes we call it skin depth. Then for second depth, the bio-optical parameter used to give an indication of light penetration in the water column is the downwelling diffuse attenuation at 490 nanometers. In literature, you see it listed as KD490. And the bigger point is that we don't have a parameter that gives us second depth directly. So we depend on algorithms. And so we have used a couple of algorithms to assess satellite retrieval of second depth, to compare it with the in-situ second depth. Where do we get these satellite-derived variables? There is a NASA website, and if you're interested in MODIS, you would select the imagery that you want. You can pick MODIS, you can pick Mires, you can pick Sentinel. There is also legacy data of CWES as well as Mires. And what you have to do is specify your study area. Lake Victoria is one of the big water bodies, so you just click on it, and you can pick the date of your data, the year, the month, and the day. So this helps us to extract images that coincide with our days of data collection. I would like to briefly discuss some of the challenges that we face. This is one of the experiences that we had. We went to collected data. When we came to the website to get the imagery, we realized that the imagery for that date was cloud covered. And what we see there is the whole of Lake Victoria cloud covered on that particular day of data collection. We also have cases where the imagery of available does not cover your specific study area. So bear in mind, you have gone to the lake, you have spent 2 or 3 days, and you want to be able to collocate your in-situ data, your satellite imagery, and this is what happens. So for people in the field, in this area of research, they will understand these intricacies. And that's why some people have put in an argument that if I have collected in-situ data today, and there's cloud cover today, hopefully I can use tomorrow's image for my work, and it should be good enough. So what are some of the findings that we have seen from comparisons of model satellite derived water quality retrievals and in-situ observations? From what we have observed is that temperature gives accurate results. In other words, we can use the temperature readings from the website, and it gives a good estimate of what is in situ. However, what we found was that satellite-derived chlorophyll A overestimates in situ chlorophyll A. So in other words, the algorithms which have been developed for the ocean and cannot directly be translated to inland lakes. And this is also in keeping with the other bodies of existing literature. And we also found that second depth accuracy depends on the model that you come up with. So you find that increasingly more and more people are developing second depth accuracy models for inland lakes, whereas many of them the algorithms which are available are mostly for the oceans. But with time, we're going to have more and more algorithms that can be applied. And we have looked at them. In 30 minutes, I don't have the time to go in depth into each and every one of these algorithms. I just want to give an appreciation of the sort of the results that we have been looking at. So this is an example of average lake surface temperature for the period 2003 to 2010. Ideally, what we want to be able to do is to go back in time and derive trends of lake surface temperature and see how if we can establish a link between climate change and lake surface temperature and what its implications are. We also, this is an example of average chlorophyll A. The beauty about this digital data is that we can model it according to years, we can model it according to seasons. We can go back in time, we can go into the future. And as I mentioned before, we are not only interested in the chlorophyll A images, ultimately, we want to determine the trophic status of a lake and see how the trophic status has varied from time to time. And this is especially important for managers, environmental managers, people involved in the management of
Dr. Anthony, we are not able to just hear you. There is no voice. There is no audio.
I think now it should be concluded.
Okay. Hello.
Sir, please carry on.
No, but what we are not able to just hear any voice from Dr. Anthony, Dr. Ravi.
I think he has lost the link actually. He has lost.
Okay, so in that case we can.
I can conclude.
We can continue, no? Okay. So to coming to the end of the session, as a chairman of the session, I just want to summarize. There are six papers. The first one was from Dr. Emmanuel. He was just talked about the geostatistics, groundwater modeling, and he has also just done the evaluation and accuracy assessment with the field truth of the particular study area, and also he has predicted the aquifer health of his study area. It was a wonderful presentation. The second one was by Professor Katiyar. He has just talked about the modeling of the river meandering. He has just taken up the part of Ganges from Kanpur, near Kanpur area, and he has given the factors affecting the meandering parameters and what the action they should take up for going for any development, land development. And the third one, and also the last one, it was by Dr. Anthony Jijidu. But unfortunately, part of his lecture we could not able to hear because of the link that just got cut. He was just mostly talking about the water quality and water monitoring aspects of Lake Victoria of Uganda. And the fourth one, it was by Dr. Swati. She has given a very good, rather lucid presentation on do's and don'ts for the people, those who are just publishing in the journals. So the other one, it was by Dr. Mohammad Qasir. He was just talking about the modeling of the olive trees for the suitable locations, keeping the climate change as an important factor. And also he has just talked about the second part as the watershed management. And then Dr. Ram Karan Singh, he has just talked about the suitability of the juniper plants where it can just grow in the arid region. And also he is using the NDVI and then the slope factors, how the whole thing it has just increased from the wasteland to the useful land. So these are all the papers which we have discussed today. With this summary, I would like to thank the organizers for just giving me an opportunity to conduct this session, and for the participants also, for because I'm just still seeing all the participants, they are just sitting, nobody has just gone except 1 or 5 or 6 participants. I thank the participants also for just giving me the support to conduct the session very smoothly. So thank you once again for the organizers for giving me the opportunity. Thank you.
Thank you, sir.
Thank you, Dr. Subramanian, sir. Now I would like to thank all the eminent speakers for enlightening the budding research scholars, professional researchers, and academicians with their research work and their knowledge. I hope it will be useful and benefited by the research scholars in their near future work. Thanks to all the national and the international participants, without whom the international workshop would not have been a success. Now I would like to invite our president of the association, Dr. Vijay Pratap Singh, sir, for the valedictory. Sir, you are muted.
Can you hear me now?
Yes, sir. We can hear you now.
Okay, because I was not allowed to unmute. So anyway, okay, thank you very much, Shalini. And after 3 days of highly informative presentations by prominent scientists, we have now reached the end of this international workshop on applications of remote sensing and GIS in water, environment, land, and society. Just to recap, about 2,000 participants registered for the workshop, which is an indication of the significance of the workshop theme, and perhaps a pointer or a norm for such meetings in the future. although there is no substitute for person-to-person or face-to-face meeting, but this online or virtual meeting perhaps might become the norm or a trend in the future in light of financial time and other constraints. 15 presentations were made by keynoters from 6 countries on several important topics. And these topics can be primarily divided into 4 categories. While organizing these presentations in what I thought a logical sequence, I'm in no way attaching any significance to where a particular paper appears in the sequence. So these categories are: the first category is basics or preliminaries, consisting of 4 papers or 4 presentations which are relevance or remote sensing and GIS technology in river rejuvenation by Dr. S.K. Subramanian, formerly from the Department of Space, Government of India. And the second presentation was on 5 forces, 5 trends, and 5 skills critical to GIS and remote sensing by Joseph J. Kursky from Esri and the University of Denver, Colorado, the United States. And the third presentation was on geoinformatics for contemporary environmental issues by Professor Joshi from Jawaharlal Nehru University in India. And the fourth presentation was climate resilient water infrastructure in complex agricultural landscapes, integration of data management and policy by Dr. F.M. Ariola from the University of Nebraska at Lincoln, the United States. So these 4 presentations essentially provided a good presentation of the basics, or what I call preliminaries, that I think we all ought to know with regard to remote sensing and GIS. The second category includes applications to environment, and this category consists of 2 presentations. One is exploring the use of Earth observations in monitoring water quality in Lake Victoria in Uganda by Dr. Anthony Gidudu from Baker University in Uganda. And the second presentation was on remote sensing in GIS modeling, based prediction of debark of Juniperus professora in El Suda Highland Kingdom of Saudi Arabia by Dr. R.K. Singh from North Cape University, India. And these 2 presentations directly relate to the environment. And I think they provide a good background of where outside of water resources, the remote sensing and GIS technology can be employed, particularly in the case of forest management, and also how Earth observations can also be applied to other areas. The third category was applications to water resources, and that consists of 3 papers, which are hydroinformatics, machine learning applications in water resources, and how IC technology is contributing by Dr. J. Carzo Paris from IHE, the Netherlands. The second presentation was on applications of remote sensing in water resources management by Professor C.K. Singh from Terry University in India. And the third presentation was on application of remote sensing in GIS for water and land management in dry areas by Dr. M. Usar from IRA Tunisia. And I think these 3 presentations are on the larger issues of water resources, not just hydrology or hydraulics or a particular component of water resources. The fourth category included applications to hydrology, and consisting of 5 papers. And the first one was on assessment and validation of evapotranspiration by using satellite-based and in situ data sets for a lesser Himalayan catchment by Dr. S.K. Jain from IIT Roorkee. And second one was on spatiotemporal geostatistical modeling of aquifer levels using physically based tools by Dr. E. Varouchaki from Technical University of Crete in Greece. And the third one was on application of remote sensing and GIS in soil erosion modeling by Professor Ashish Pandey from IIT Roorkee in India. And the fourth one was on application of remote sensing and GIS in reservoir sedimentation assessment by Dr. J.V. Tyagi, National Institute of Hydrology, Roorkee in India. And the fifth paper was on remote sensing and GIS applications in planimetric modeling of river meandering by Dr. A.S.K. Katiyar from MANIT Bhopal in India. So these four presentations were were highly technical and very informative. And the another paper, which is very important, not necessarily technical, but very important, was on research integrity and ethics by Dr. Swati Maharishi from Applied Sciences and Engineering in India. And so these essentially pretty much concluded all the presentations, but they were all quite informative, and they provided a broader perspective and at the same time scope of where GIS and remote sensing can be applied to address the pressing issues. As I remarked right at the opening, I think we as technicians or as technologists or scientists or whatever we want to call ourselves have to get out of our compartmentalized or boxed mentality and view natural resources as one, as we in India have long believed. We subscribe to the concept of Brahman, which in hydrological terms is really nothing but a continuum of three spheres: the hydrosphere, the atmosphere, as well as the combination of stratosphere, lithosphere, and pedosphere. And this is something that we have been having in our mind for many centuries. Nobody really knows. People often say for the 5,000 years. I would tend to argue that it may be much, much more than that, maybe 25,000 years, maybe even longer than that. But in any event, that's not really as important. What is important is we have to view ourselves as a community of scientists where each one of us can make a contribution to the larger core of our civilization, to our humanity. But I don't mean to give a lecture on the humanity or human philosophy, but let me say once again that there was very active participation in the deliberations, and I'd like to thank all the keynoters for their presentations and making this workshop a successful one. Without their presentation, this workshop would not have been as successful and as fruitful and informative as it has been. The workshop was jointly organized by International Association for Water, Environment, Energy and Society, IHE Delft, and Institute for Water Resources in association with Rabindranath Tagore University, National Institute of Hydrology, CSIR, EMPRI Bhopal, Valmi Bhopal, North Cap University, and Dr. C.V. Raman, University Bilaspur. And I thank all these organizations for their contribution to the organization of the workshop. This workshop would not have been possible without the dedication, the hard work, and leadership of Dr. Shalini Yadav and her father. Fortunately, Dr. R.N. Yadav is Dr. Shalini Yadav's, daddy or father or whatever you want to call. And they both are in the same area, even though her father is a mathematician by training, but apparently he diverged into a more important area, which is water, environment. and the entire team of conveners and organizers. Without their commitment, without their dedication, without their hard work, obviously all of us would not have been together, albeit virtually. So they deserve a special applause. And I wish I was there in person so we could all clap together for quite some time. So to conclude, I would like to thank all of the participants, and I hope as well as the session organizers for their commitment, for their professionalism in concluding the sessions. And I hope Dr. Yadav and his team or her team or their team will now try to bring out the workshop proceedings, and certainly Swati Maharishi and I can help in that endeavor. So with that, thank you once again. And it was a pleasure for me to speak to you, albeit virtually. And the other thing I would like to say before signing off is that for me, it's a particular pleasure because I know most of the keynote speakers, some more personally than others, but almost all of them I know. So it's always a pleasure to speak to the people you know. And many of the participants, I could not see their faces, but I also know many, many participants, not only from my own country of India, but also from other parts of the world. So with that, thank you once again, and you all have a good evening or good day or good morning, wherever you are. So for me, it's 9:35 in the morning, and actually I had another meeting which I postponed because Dr. Yadav insisted that I come and conclude the workshop. So with that, thank you once again. Stay in touch, and I hope and pray that all of you stay safe and healthy along with your families, friends, and relations and loved ones. So thank you once again. So Shalini, the floor is yours. We cannot hear you.
You are mute. Okay.
Thank you, sir, for the appreciation, but I am just walking on the path guided by you and Dr. Yadav, sir. And thanks for sparing your valuable time and giving your valuable suggestions and comments on the organized workshop. Thank you. Now I would like to invite Dr. Yadav, sir.
Well, first I say good morning, good afternoon, and good evening to all dignitaries, speakers, participants. First, let me express my sense of gratitude to Professor Singh, who has always guided me for doing the good things and whatever I am doing, only because of his continued guidance and advice, especially in the area of water environment. So thank you, sir, so much, and blessing to all of us. Now, I just summarized that in last 3 days, we have 3 sessions. First day, we have 6 keynote speakers from the, first day we have 4 keynote speakers from the different part of the world. And the second day we have
6 speakers.
We have 5 keynote speakers, because on that day we have scheduled 7, but 2 dropped due to some other regions. And third day, we have got 6 keynote speakers. It is a technical workshop. Definitely we had some technical internet problem, because Dr. Anthony was unable to continue this talk because of the internet problem, connectivity problem. So I express my heartfelt thanks to all the chairmen, especially the first chairman, Dr. Jain, Saraj Jain from NIH, and then Professor Vijay Kant Verma, Chancellor, CBR University, and today Dr. S.K. Subramaniam, Chief of the NRSA, workshop smoothly. Now I can invite to Professor Santosh Chaubey, if he's here, to just express his views about this workshop. If he's not here, then I would like to request Srimati Urmila Shukla, Director Valmi. I'm sure she's not also here because she is busy in some personal activities in marriage. I request Professor V.K. Verma, Chancellor CBRU, if he's here. I think he is also not here.
He is here, sir. He has joined us. Yes.
Okay. Professor Verma.
Yep. Good evening, everyone. How efficiently the new normal of human interaction with social distancing has been adopted by academicians, scientists, and researchers in the world. This 3 days international workshop has provided a beautiful example of that. 15 eminent experts sharing their research outcomes with 2,000 participants locked up in different locations around the world shows that COVID-19 has actually brought the world of academicians and researchers closer, though ironically we call it social distancing. This 3 days marathon has pumped in so much of information, right from basics to advanced knowledge on application of GIS, GPS, and remote sensing, that I think it will take quite a few days to digest. Water, environment, land, and society are the most critical elements, and if we do not resolve burning issues in these areas in time, our survival itself will be endangered. Remote sensing and GIS, with the use of advanced computing technologies and tools like artificial intelligence, big data, machine learning, IoT, etc., can provide very good solution, and we learned so much on these issues. They were very well covered by all these 15 experts who provided knowledge right from the basics to advanced applications. It can provide solution to all these problems, and of course, if taken in right earnest, it can bring in sea change. We heard scientists and researchers right from the field with their actual research outputs. The workshop was, in my view, a grand success. I convey my sincere thanks to everyone, organizers, participants, and above all those 15 speakers. We eagerly look forward for such gathering in future also. I congratulate Rabindranath Tagore University, Dr. C.V. Raman University, Bilaspur, Springer, CSIR, EMPRI, Valmi, NCU, IHE, Institute of Water Education, and International Association for Water, Environment, Energy, and Society to create such a wonderful world-class event on such current and relevant topic. Thank you very much, all the participants, to this very, very important event. Thank you very much.
Thank you, sir, for your address. Now I request Professor Gerald Corzo, if he is available. Dr. Gerald, I think he's not available. He's not online.
He is not available. He is not available.
I request Dr. Saraj Jain, former director NIH.
Yeah, am I audible?
Yes, sir, you are audible.
Yes, sir. Yes.
Thank you, Yadav, and namaskar, everyone. Actually, for me, this name of your association, that is International Association for Water, Environment, Energy and Society, brings the memory of a conference that we organized in 2009 at Delhi. It was an international conference called WEES, or Water, Environment, Energy and Society. And that was jointly organized by NIH with Professor VP Singh. And it was a very successful conference because a lot of people from different parts of the world came, and we had some very useful discussions. So I'm very glad that this association has come to a maturity where now it is organizing conferences on very relevant topic. And the topic that you have chosen related to remote sensing and GIS application, it's a very timely topic because in last 2 decades or so, we have seen explosive growth in the development of remote sensing and GIS technology. And particular to water resources, this technology is now being used for measurement of hydrological variables, be it precipitation, evapotranspiration, soil moisture, even river flows. In addition, it measures a lot of spatial data which we are now routinely using, like land use, land covers, DEM, or groundwater withdrawal. For example, the GRACE mission has given some very useful information about the changes in terrestrial gravity because of the large scale of groundwater. That apart, these days it is very difficult to find a model which does not make use of inputs generated by remote sensing technology. So I think water professionals are at the forefront of using this technology for modeling work, for deriving very useful information for decision making. This conference provided a platform to all of us to come closer to listen from different experts, find out what they are doing and share their experiences. So I would like to thank the organizers for organizing this conference on a very important and timely topic. I would also like to thank them for making me a part of this effort and for providing me also this opportunity to interact with large number of experts from different parts of the world, which would not have been possible if we were to meet physically. So thank you very much for all the efforts. Keep doing good work, and let us hope that we will make full use of this platform that we have with us and meet at least virtually and share the experiences. Thank you and bye.
Thank you, sir. Now I request Professor Brahma Prakash, Vice Chancellor, RNTO, if he is available. Dr. Brahma Prakash.
I think, sir, he is not available.
Okay. Now I request Professor R.K. Dubey, if he is available, Vice Chancellor, CBRU, Bilaspur.
I think Dr.
Brahma Prakash is here.
Yes. Okay.
I don't know what. Am I audible?
Yes, yeah. Sir, you are audible.
I was here throughout since last 3 hours, sir.
Sorry, sir.
First of all, I am really thankful to all the organizers for inviting me to get associated with this very important workshop. So all the respected patrons, the Dr. Vijay P. Singh, the President of IVs, Dr. Yadav, the Vice President of IVs, also Dr. Sukant Jain of NIH, all the organizers, speakers, important. The participants of this workshop is roughly 2,000 as I see the figures, which might be up to 2,000 totally in all. So this was very interesting discussions on this prestigious workshop on the application of remote sensing and GIS, particularly related to the land, water, environment, and the most important part, we have kept the society in focus because these are technical things, but human beings has also been given the importance in what is the correlationship. So I would like to congratulate the entire organizing team and the participants who has very actively participated in this 3 days workshop untiringly. Only the one thing which is bothering me is a gender bias. I think 95% participants are the male and the participation of the female is hardly 5%, which I could see. So that is what worrying me, whether this GIS and remote sensing is only confined to the male participants and why the female participants are very less. So one, that society, when we say that we are also concerned with the society, this is also to be seen it. Though Dr. Salini Yadav has represented the female participants, but the number of total participants was very less. So how to popularize the subject, so or how to remove the gender bias, that is to be seen by the organizers and by the people who are sitting at the policy level. So how to encourage the women to participate. Then we have talked about the problems related to the applications of the remote sensing and GIS, particularly with respect to the water, environment, land use, and most important is the society for which we have been working for. It has been concluded that there are multi-discipline problems, and therefore, as I conclude the entire discussions of 3 days, the focus research agenda with the objective of identification of the problems related to the all applications and technology development with respect to the problem-oriented solutions, irrespective of what are the problems and what are the alternatives we are looking at. So what basically the alternative findings, the research with a focus on science, defense, and also the society-oriented applications like geohazards, assessments, geohazard assessments and monitoring, the biodiversity characterization, the irrigation and the drinking water management, the watershed management, including the groundwater, are the areas which is to be given due emphasis by the government and augment all the physical, financial, and also the manpower essentials which is required for this sector of remote sensing and GIS. Anyway, with these constraints, still the scientists are doing the very good work. So again, once congratulations, and expect that government will augment all these financial and manpower essentials for this. So congratulations to everyone for this wonderful workshops. With this, have some kind of actionable. I hope when you come up with the recommendations, so recommendations should clear cut be actionable recommendations so that the acceptance of the same by the policy makers at the top for the benefit of the mankind to the remote sensing and GIS can be seen. So if recommendations are not actionable, then this workshop will not be lead. So I request the organizers to come with a clear-cut recommendations which is actionable by the policy maker. So we can get the benefit of these workshops and whatever the intellectual discussions we had in the last 3 years, they can be put into action as such. Last point of this workshop was totally as I already mentioned, that dominated, so that female participation is required, or it was almost negligible. But the content and the discussions and the recommendations were good. Only how to summarize them, and the benefit will only come when we are able to influence the policymakers, particularly at the government, to how they can augment the resources to get the society can get better to the back to the society. So thank you very much for inviting me to participate. I have participated in few of the sessions and I was really impressed. So whatever that my reservations I have already explained, and I hope the policymakers will also be taking a note of it also. And once again I just repeat, the recommendation should be in the form of acceptance by the policymaker, then there will be use of these kind of workshops if you put the recommendation into action. So thank you very much. And on the behalf of Rabindranath Tagore University, I thank all the organizations for inviting us and getting associated with this wonderful workshop, which is for the benefit of the mankind. So thank you very much and all the good luck.
Thank you, sir. Now I request Dr. R.K. Dubey, Vice Chancellor, CBRU. Dr. Dubey, are you available, sir? He is not available. So I request Dr. Gerald if he is here. Dr. Gerald is not here.
Dr. Kobus is there.
So,
Dr. Kobus is there online.
Kobus?
Yes.
Dr. Kobus? Dr. Kobus?
Dr. Yadava, can you hear me?
Yes, we can hear. 3 minutes for you.
Thank you very much for the opportunity, and thank you for being able to be part of the conference. I'm very sorry that I couldn't present as what you've invited me to do due to other work commitments, but I've tried to attend most of the sessions. I would, however, with your permission, and let me just start off correctly by thanks our chairman, Prof. Singh, for his attendance, and of course for Dr. Salani and yourself for arranging this excellent conference. But may I use this opportunity to extend all the participants of this conference to the joint conference between IMESA, that is the International Municipal Engineering Institute of Southern Africa, and the International Association of Water, Environmental and Energy and Society this year. But of course the virus had other plans with us, and we've decided to extend or postpone that conference to next year. So may I just use this opportunity to invite you all and to make sure that you keep a close eye on our website, the Institute's website, for our conference in Cape Town in South Africa between the 17th and the 19th of November next year. We are looking towards an event. Hopefully we would be able to meet again. We really hope like that, despite the new norm. But we are looking towards an excellent opportunity, expecting about 1,000 delegates in beautiful Cape Town. And besides congratulating all the presenters with excellent presentations of this very, very valuable topic. And we know this is where the world is going. We know that if we don't adapt, we will just be left behind. And we really need to cherish, like our president has said just now in his concluding remarks, our environment, and GIS is taking part and trying to help us to solve this in a holistic way. So please make a note somewhere, 17th till the 19th of November, Cape Town, South Africa, a joint international conference between the Institute of Municipal Engineers and the Association of Water, Environmental, Energy and Society. Please keep an eye on our website. Thank you, Dr. Yadava. Thank you very much, Shilani, for allowing me the opportunity. And have an excellent evening. Good night.
Thank you, Professor Kobus. Thank you so nice for sharing your views. Thank you. Now, just I record here that there was a appreciated number of participants in this conference, and it is live on the YouTube. A feedback form has been sent to all the participants for seeking their views on the workshop, and a draft of recommendation on the outcome of this workshop shall be sent to all the experts for their comments. After incorporating the comments, a final recommendation shall be submitted to the different agencies of the government and the stakeholders for consideration. Once again, I thanks to all for sparing your valuable time, having patience to listen us, and sharing your views. So once again, I thank you so much for all your contributions, for your patience, and many support where you have extended. Without that, the workshop is not possible to have the success. Thank you so much. Charlie?
Yes, sir.
Rabi?
Yes. Sir, can I have a vote of thanks?
Yeah, please go ahead.
Because already we have expressed our vote of thanks by all our from organizational side, but still I take this opportunity and feel great honor to express my vote of thanks on behalf of organizing committee of this 3-day international workshop on application of remote sensing and GIS. So I would like to express my vote of thanks to Sri Professor Santosh Chaubey sir, with the Chancellor of RNTU, who could not make it today. And we are extremely thankful to Professor VP Singh, President IAVs, for his continuous support to organize this workshop. And we are extremely happy to express our vote of thanks to head of the various organizations who were the partners of this workshop. Srimati Urmila Shukla, Director, Water and Land Management Institute, Government of Madhya Pradesh. Professor V.K. Verma, Chancellor, CVRU. Dr. Jaivir Tyagi, who is Director of National Institute of Hydrology, Government of India. Dr. Sharad Jain, as Director of NIH. Dr. A.K. Srivastava, Director CSIR, AMPRI, India. Dr. Girard Augusto, IHE Delft. Dr. Brahmaprakash Petia, Vice Chancellor RNTU, Dr. R.K. Dubey, VC CVRU, and our special thanks to Dr. R.N. Yadava, who is the Vice President of IVs, for his constant support to organize this organization with this workshop. I can see Dr. Amadar Singh Sahab here, Senior Scientist from CIAE, ICR, Government of India. I especially thank to him for his 3-day continuous presence. I could see him. I am also thankful to our chairman, who chaired our sessions for 3 days, Dr. Sharad Jain from NIH, Dr. V.K. Verma, Chancellor CVRU, and Dr. S.K. Subramaniam sir, former scientist from ISRO. They have fantastically chaired the session and concluded all the information and the presentations, and they have chaired the session very nicely. We express our gratitude to all the eminent speakers from India, from USA, from Uganda, from Tunisia, Greece, who have delivered wonderful and informative lectures and shared their expertise and nice presentations, and showcasing application of remote sensing in water resources and any other sectors. I hope and we hope that this will help to all our participants, who are mostly the researchers, academicians, students, professionals, and this workshop will help them to take up their work. I request all the speakers to send their PPTs of their presentation so that we can share, because we have got number of requests from the participants to share the PPT. So we will try to get all the PPTs from the speakers and we will try to provide it to all the participants. We are extremely thankful to the participants without whom this workshop cannot be successful. They have shown great interest to attend this workshop, and I can see around 1,000 attendants hit to this site, and around 2,000 and to more than 2,500 views on YouTube of this program. And I sincerely thanks to all the organizers who have taken a lot of pain to organize this workshop since last few days. I especially thanks to Dr. Shalini, Madam, Dr. Vivek Bhatt, Dr. R.K. Jaiswal, Dr. J.P. Shukla, Dr. R.K. Singh, Dr. Manish Upadhyay, and Shri Sukan Jain, who was hosting all this and managing all these Zoom meetings. And all other, I thanks to all other members who have directly and indirectly extended their help to this workshop. I request all the participants to submit the feedback. We have already sent the link on this chat box. Otherwise, we will also send an email to them to submit the feedback. Then, as it is an online platform, so there were some flaws and some problems in the internet connection. So we express our regret for that. And I hope this is a pandemic time. So I hope all the participants and everybody will take care of themselves, their family, using mask, sanitization, and social distancing. And we have all got all the emails. And whenever such a next workshop we will organize, we will definitely directly send the request to you to attend that workshop. I thank you all very much. Now I give it to Shalini Madam to.
Just I will take, Ravi, just I will take 1 minute.
Okay, sir.
Gerald is online. He will take 3 minutes, so just bear him. Dr. Gerald. Dr. Gerald.
Hello, can you hear me now?
Yeah.
Yeah, thank you very much for giving me this opportunity to be in the last minute of the closure. And thank you all for participating in this great workshop. I noticed we had participation from all over the world. I received even emails from Cuba, from South America, Africa. So this was a really unique experience. So great congratulations for all the people that participated and helped on organizing this. Also, I noticed the level of the presentations was quite good. Everything was really nice, and I hope we can contribute and continue doing this type of activities. So yeah, Professor Dr. Javava, I think this is one of your good achievements in this organization, and happy to be here. Thank you all again.
Thank you, Dr. Gerard. It is your support.
No,
Success.
Good.
Now, Shalini.
I think vote of thanks has already been given by Ravi sir, but once again, I would like to thank all the eminent speakers and the participants, the organizers, the organizing institutes who were the host, and the technical team. Special thanks to the technical team, especially to Sukant sir and Bhatt sir. I hope I am right if it is Bhatt sir. Because without the technical support, nothing would have been possible in this pandemic time. So thank you all for making this workshop a grand success. And in the near future, we'll definitely get in touch with all of us whenever we are organizing any workshop or a conference. Thank you once again.
Certificates shall be issued to all the participants.
Yes. Certificates will be sent via email, and the PPTs as soon as we receive the PPTs from the respective presenters, it will be sent to the participants accordingly, whichever is desired by them.
Sir, can we take view of any participants if he raise the hand?
Yeah, sure, sir.
Yeah, if someone raising the hand, you can raise the hand. Mr. Shiv Kumar. Okay, sir. I'm just unmuting Shiv.
One Omar Crazy is also there. Yes, Omar.
Shashi Kumar.
Suka, can you please unmute Mr. Omar Crazy?
Mr. Shashi Kumar, you can speak.
Yes, sir. It was nice 3 days experience, sir. Wide variety through global one. So it will be very helpful.
Hello.
Okay, Mr. Omar KZ, Omar, I am 1 minute.
Yes, Mr. Omar Crazy wants to give
Yeah, this is Omar Sisse from the Gambia, West Africa. I work with the National Environment Agency. It is very interesting and educative to attend this workshop. I think this will add a great value to our work as I work with the Environment Information System in my agency. So I thank the organizers, and I also look forward for future collaboration in relation to all these activities that will help us to manage our natural resources and environment. Thank you very much. Greetings from the Gambia, West Africa.
Thank you.
Anyone else?
Usar Shankar.
Okay.
Usar Shankar. Suka, can you please unmute Usar Shankar?
Usar, yeah. Usar Shankar, I am unmuting. Okay. Mr. Usar Shankar, you are unmuted now. Yeah, please. Please, you are not audible.
Your microphone has some issue.
Yeah. You are not audible. Sorry, you are not audible.
Tafsir Ali, sir.
Yeah, we will take everyone, please. Mr.
Tafsir Ali.
Tafsir, TAP.
TAF.
Yeah. Mr. Tafsir Ali, I have unmuted you. Please. Mr. Tafsir Ali. Okay, next one. Gagandeep. Gagandeep Singh, I have unmuted you. Please.
Thank you, sir. Thank you.
First of all, thank you very much, sir, and all the organizers for providing us an opportunity to attend such a wonderful brainstorming workshop on water resource management in developing country like India, where water are discriminately used. So I congratulate all the organizers and the speakers for your wonderful presentations and sharing your knowledge with us. Thank you very much, sir.
Ramadhan Singh, sir, do you want to say something? Take it, sir. I'm opening. Sir, you are unmuted. Please. Sir.
Thank you, Dr. Yadav, sir, Dr. Salni Galgote, Dr. VP Singh, sir, and so many of my senior colleagues, and many of them are familiar with them. But continuously 3 days I've attended your complete workshop. I did not miss hardly for 1 hour. I totally attended from all 3 sessions, 3 days, and 2-3 things, because this is remote sensing in GIS. Presently, I'm involved in other fields, irrigation, precision irrigation, water management. So earlier I worked in this area. I have an in-depth knowledge of this hydrological studies with GIS, remote sensing, and all this. Regarding this workshop, really few presentations, they were very interesting and very directly related to the society, and directly applicable to our Indian condition, like our semi-arid region and some of the our called water quality aspect, depleted groundwater resources aspect, use of such remote sensing GIS technologies. It is almost balanced list. Even though today also a lot of new technologies, new interventions like that, you can say AI and what you call that IoT based interventions are integrated with this GIS remote sensing. Really, they are putting very giving good results and very informative. They are very helpful in finalizing strategies and management of this our water source problem, handling society issues related to the water. So thank you very much, sir. For once again, thanks each and everyone of this workshop as an organizers, as a participant, as a presenter. All are thank you very much for their contribution and giving their valuable time. Thank you very much.
Thank you, sir. Mr. Nantel Sinta. Yeah, Nantel Sinta.
Zubair Ahmed, sir.
Yes.
Ravi, sir.
Sir,
I'm here.
ठीक है madam. Equally.
Yes, hello.
Please. Please carry on. Please speak, Mr.
Hello.
Nantel Sinta. Okay.
Hello,
carry
I'm
on.
speaking.
Yeah,
Anyone
you're
can?
audible.
Yeah.
I'm audible.
Yeah, you are audible.
This is
Yes, yes, you
Nathaniel.
are audible.
Thank you, sir. This is Nathaniel Setota from Ethiopia. I'm a lecturer in Jimma University, Institute of Technology. And I'm interested, first of all, I would like to say thank you for the organizers and the workshop helped me a lot because my research area was application of remote sensing in hydrological modeling. So your workshop gives me a lot of information and it helps me to advance my understanding. So once again, I would like to say thank you, the organizers and a lot of the doctors who shared their experiences, their knowledge to us. So thank you for giving this chance. Again, thank you.
Okay, thank you very much. Who is next one, madam?
Zubair Ahmed.
Okay, okay. Spelling?
Z-U-B-A-I-R. Zubair Ahmed.
Z-U. Zubair Ahmed. Okay.
Yes.
Yeah, Mr. Zubair Ahmed. Please accept invitation. Yeah, you can speak now.
Hi, good evening. Can you hear me, sir?
Yeah,
yes.
you are audible.
Sir, I would like to say thanks to all organizers of the same wonderful event. This is Zubair Ahmed. I am serving as a senior hydrogeologist at Public Health Engineering Department from Pakistan. So it was a very informative, very fruitful and very tremendous event. And I would like to thank to Dr. Gerald, Dr. Shalini and Dr. Yadav that they provided me such a wonderful platform. The same event will boost up my professional and as well as my research skills. These all PPTs should be provided to us, and these will help us in our doctoral research. And I would like to say thanks again to all organizers, to all national and international participants, speakers, and sponsors. Thank you, sir.
Okay, thank you very much. Mr. Hisham.
Sir, next is K-I-P-K-E.
Okay, I will take first. Here, Mr. Hisham has raised the hand.
Okay.
So please. Okay.
Yeah, hi everybody. Thank you very much. My name is Hisham Abdul Majid. I'm an assistant professor at Imam Abdurrahman bin Faisal University in Saudi Arabia, but I'm currently in UK joining this international conference. I really would like to thank all the organizers for the great effort on this. And I believe this is a hard work done and well established and well provided platform. So on behalf of our university, I'm also the head of continuous education committee in the college. So I would like to grasp this opportunity to call for any kind of collaboration that's possible with our university, with our different departments, environmental engineering, transportation, mechanical and energy, and biomedical engineering. And also would like to join any kind of collaboration with I'm also the head of the Geomatics and GIS research group in our college. So please feel free to communicate, and thank you so much for the organizers in having this platform. And I'm sorry for my child here is also enjoying the whole collaboration. So thank you so much.
Please send your email.
I will. I put it in the chat. All right.
We are
Hello?
God is we are God is
Please name the name of the university, Ravi sir. Can we get the name of his university once again?
You can send me mail.
You can unmute Mr. Hisham. Okay, fine. Anybody who want to speak?
Hello.
KIP. 1 minute, please. I am just.
Yes.
Hello.
Okay.
Yes, join, sir.
Hello.
Please speak.
Can you hear me?
Yeah.
Yeah, my name is Collins Kipkemoy.
Some noise.
Yes,
Okay.
please go ahead.
And I come from Kenya. Sorry?
There is some noise in your voice. Some disturbances are there, I think. We are not listening you properly. We are not getting your voice. Can you speak again, sir?
Hello. Can you hear me?
Please. I think he is not audible actually. Can we take next participants who want to?
Next is
Anybody want to speak?
Okoro Mac Dennis. OCOROMAC.
OCO.
ROMAC.
Okay. Please. Mr. Dennis.
Yes, so
Okay.
yes, please.
Yeah, please.
Hello, I am Mr. Tormat Dennis. Professionals in field of water engineering at IIG. This was wonderful and informative sessions. It's the real show that as researchers, if we unite around the world, we can make critical decisions and analyze information that can reflect the world at its environment and its event. Thank you very much. I would like to thank all the organizers and thank all the participants who have joined for these wonderful informations. May we in future receive these kinds of collaborations that we see how I can distribute or disseminate information resulting from a water sector industry. Thank you very much. Thank you. Thank you.
Thank you very much. Mr. Govan. Mr. Govan. Yeah, please.
Hello.
Gigi, please carry on. You are audible.
Hello.
Yeah.
Sir, this is Gopakumar from Kerala.
Okay.
Hello.
Yeah.
Can you hear me, sir?
Yes, you are audible.
Oh.
Sir, I think his internet connectivity is very low. That's why his voice is not coming properly.
Can we take another participant, sir?
Mr. James want to speak something. Mr. James.
Yes, James Story and
James, James.
Hello.
Yeah, can you
hear me?
Mr. James.
Can you hear me?
He's also not audible.
Hello.
Yeah. Mr. James, please.
Yes. I'd like to thank the organizers for organizing this seminar, this conference. We have learned a lot. I'm an irrigation engineer from Muriwanga University of Agriculture and Natural Resources, Malawi. And we have benefited a lot from remote sensing and GIS application on this topic. And I hope that this conference will help us and in our professional careers. Thank you once again. Thank you.
Thank you very much. Anyone else?
next is Nang Mame, NANG.
1 minute.
He's unmuted, sir.
Anyone else?
Nang Mane. NANGMAME.
Right.
Ron Antino Bayo Gireko.
He is not audible. No. Anyone else? Mr. Gohar, you want to, Miraj, you want to speak? Mr. Miraj? Yeah. Mr. Miraj? No, you are not audible. Mr. Miraj, you are not audible. Anyone else?
Dr. Anthony.
Dr. Anthony, I think is not here, madam.
He's not here.
And this Kipkimoi, is he audible? Yeah, we are facing.
Kipkimoi, he want to speak, but we are not getting his voice actually.
Okay. Another hand is Rajab
Yeah.
Nama.
Mr. Kipkimoi. Yeah.
Hello, can you hear me now?
There is some problem actually in your audio. Some noise is there, so we are not getting your voice.
Okay, fine.
We are very sorry. I think there is some problem from your internet side. We are very sorry for that.
I think we can receive his views on our mail.
Yeah, you can send your views on mail. Okay. So I think this is over, madam. And just take the
one
leave.
last engineer Rajab Nampola.
Spelling, madam?
RAJAB.
Sir, he is unmuted, sir.
Okay, Mr. Rajab. Mr. Rajab.
Thank you very much. Yeah, thank you very much, guys.
Yeah, please.
Hello, are you getting me? Of the conference you got in that is in East Africa, and I'm a user of GIS, but I'm not that great expert. But such this conference, I got it through. I was given a link through a colleague who is at International Water Institute, and it has been a great experience. I only request that the next conference you allocate a little more time for discussion. You give us one session of at least 1 hour for discussion in the entire workshop. Just allocate us 1 hour for discussion, because there are some things we also want. We are really great beneficiaries, and there are some things we want to bring to the lecturers. Otherwise, I thank you very much, and we hope to see more of this. Thank you very much.
Thank you very much, because I think he has given good idea to have a discussion for 1 hour after the workshop, so that everybody can share his views.
Yeah, we shall incorporate it.
Okay, next time. Who else?
Some Professor Sintayetu, SINTA. TAYE.
He is unmuted. Mr. Abibe, can you? Yeah.
Yes.
Yeah, please.
Can you hear me?
Yeah, we can hear you. Please
okay. Thank you very much. My name is Sintayo. I am from China Institute of Water Resources and Hydropower Research. Currently, I'm a PhD student, and the contents of this conference is really helpful for me. And thank you very much for this impressive conference. Actually, I was a student of IIT Delhi for my MTech program. So I know that spirit, working hard, and such good technology activities. So I think this conference is very helpful for me and for other PhD students like me. So thank you very much once again. I hope in the next time we can meet in similar conferences. Thank you very much.
Thank you very much. Thank you for your appreciation. Anyone? Yes.
Lastly, we can take to Professor Niang Mame once again, if he is audible to us, because he's again.
Samuel, Nian Meme, yeah. Mr. Nian Meme, Simon, yeah. You are unmuted. Please speak on.
Hello, everyone. Hello.
Yes, carry on. Please carry on.
Hello, my name is Mamse Munyang from Mauritania. So thank you for all to giving the opportunity to participate in this section. This talk, I was not able to participate fully, but happy even to have assisted. I'm a young professional and member NGO, so I'm grateful to you. Thank you.
Thank you. Thank you, madam. I think
Now
we can take leave.
Yes, sir.
Sir, last word from your side, sir. Yadav, sir. And good night.
I thanks to all participants, organizers, speakers, chairman of the technical sessions, and our technical team. Without that, it was not possible. So I'm really thankful to all. So next time we are going to meet all of you, I think within a couple of months. Please wait for our next reminder, next request for participation in an international conference. It may be possible sometimes either in March or April. So thank you so much once again.
Thank you, sir. Good night.
Okay, good night, sir.
Good night
to all.
Thank you.
Good night to all.